Ollama is an open source tool that simplifies running large language models locally on your personal computer. In this course, you'll learn how to set up and use Ollama. This hands-on course covers polling and customizing models, REST APIs, Python integrations, and real-world projects like a groceryless organizer, RAG system, and an AI recruiter agency. Paulo created this course.
Hello and welcome to this mini course. I'm very excited that you're here because I know you want to get right in and start learning about Ollama and building AI-based solutions using Ollama. First, let me go ahead and introduce myself again, which is always awkward. Okay, my name is Paulo Deschone. I am a software, AI, and cloud engineer, but most importantly, I am an online instructor. And I have taught over 280,000 students all over the world in about 175 countries, skills ranging from building mobile applications, Android, to learning AI and cloud technologies. So this is what I do, and I love what I do. What is this mini course about? I want to show you how to leverage Ollama and its many models so that you can build AI solutions, AI applications locally for free. Usually the structure that I like to follow and has proven to work is in the beginning or the first part of the courses, I start with the basics, the fundamentals, as well as theory concepts, because I think it's important for you to also understand the theory before you go into hands-on. And then the second part is usually hands-on, but sometimes I like to mix those two together so that it's more exciting and you don't get bored. Okay, so I know you're very excited to get started, and I'm excited that you're here. Okay, let's go ahead and get started. Well, this course is going to be about Ollama. That's the main thing. So we're going to learn how to build local large language model, LLM applications using Ollama. So the idea is that we're going to be able to use Ollama to customize our models, meaning that we are able to use different flavors of models so we can test them around. And all of that is actually going to be free, which is very exciting. And also we're going to be able to build RAG systems, so Retrieval Augmented Generation systems that are powered solely by Ollama models. Keep in mind, all of this is going to be for free. You're not going to have to pay for anything, okay? And we are going to learn about tools and function calling when we are using these Ollama models, so we can aid our large language models that are going to be using with more things that they can do. Okay, I'm going to look at all of that. And ultimately, I'm going to show you how to use Ollama models to build full-fledged large language model applications using these models. Okay, keep in mind, all of these models are going to be for free. We don't have to pay a dime to use these models. Now let's talk about who is this course for. Now, this course is for developers, AI engineers, open-minded learners, machine learning engineers, and so forth, as well as data scientists. So if you are somebody who is willing to put in the work and wants to learn about Ollama and build local LLM applications, then this course is for you. Now let's talk about course prerequisites. In this course, I assume that you know programming. This is a very important skill, obviously, and I expect you to at least know the basics. You'll be seeing a lot of Python in this course, so understanding how Python works, how to write Python code is obviously very important. You also need to understand the very basics of AI, machine learning, large language model. You don't have to be an expert, but just have some general understanding. Keep in mind also that this is not a programming course because I'm not going to be teaching you how to program. And most importantly, I always tell my learners is that you have to be willing to learn. And if there are things that you need to go and brush on, just go and do that and come back to the course. But most likely you won't need to go anywhere but continue in this course and learn as much as you can. So most of my courses, I have this mixture of two things. I have theory, so this is where we talk about the fundamental concepts, the lingo, and so forth. And I have hands-on, because it's all about actually doing things. That way you actually understand and know how to get things done. That's the whole point. And so the thing is, I'd like to do a mixture of both. And sometimes we have more hands-on, and sometimes we may have more theory. But I try to balance it all out where we have a mixture of both, because I believe that at least that is important for you to have both in your learning process. But in this course, you are mainly going to be focusing on hands-on, although you will still have some theory fundamentals as well. All right, so let's look at the development environment setup. So in this case, you know that this is all about Python, which means you'll have to have Python installed. And also you have to have some sort of a code editor. For me, I'm going to be using VS Code. So you don't have to use that if you don't like it, but that's what I'm going to be using. You can use whatever you want. Okay. Now, I'm not going to go through the process of installing Python or VS Code or anything like that, because you should be able to have that. If not, you should be able to do that on your own. So one place that I always recommend people go is to this link here, kinsta.com, knowledge base install Python. There are many places online where you can learn, or they will walk you through the installation of Python if that's your case. But this seems to be one of the best, my favorite. Okay, so if you don't have Python installed, please go ahead and get that set up so that we can continue in the next videos. Now we have everything set up on our machine and we're ready to go. So we're going to do a deep dive into Ollama so you understand exactly what Ollama is, how it works, and what problem Ollama solves. All right, so let's go ahead and get started. Now it's time for us to do the deep dive in Ollama, so we understand exactly what is Ollama, what is the motivation behind, and the advantages that Ollama brings for us developers. Okay, so first let's look at Ollama. What is it? Ollama is an open source tool that is designed to essentially simplify the process of running large language models locally, meaning on your own hardware. The idea here is very simple. As you know, right now, if you want to run large language models, or if you want to use a model, large language model, in this case, just a model, most likely you'll have to use OpenAI, ChatGPT, and so forth, and many others out there that are paid. And the thing is, with Ollama, you don't have to pay for anything. It's free. And that's the beauty. So the idea is that Ollama sits at the center and allows us developers to pick different large language models depending on the situation, depending on what we want to do. At its core, Ollama uses what we call the CLI, which is Command Line Interface. What this does is it manages all the things in the back end. So the installation and also the execution of different models. But all of that, again, keep in mind, it's all locally. You will see as we go through that Ollama abstracts away the technicalities or the technical complexity that are involved when we want to set up these models, which makes advanced language processing accessible to a broader audience, such as developers, researchers, and hobbyists. In a nutshell, Ollama provides a straightforward way to download, run, and interact with various models or LLMs without us having to rely on cloud-based services or even dealing with complex setup procedures. Rather, what is the problem that Ollama solves? Now, when we talk about large language models, we are usually talking about this thing called RAG systems, Retrieval Augmented Generation. The idea is very simple, is that we have documents. Those documents are chopped into smaller chunks, right? And then we pass those through a model that is responsible for creating embeddings, which is the vector representation of these chunks. Those embeddings are saved somewhere, and then a query comes in, goes through the same process of embedding, right? And then once we have this embedding, that is indeed what's actually used to query, do similar search internally in a vector database, so that we can then pass all that information, right, through a large language model, and of course, get the response. Now, again, usually what happens is that all these models that we need to run a RAG system, for instance, we may need to pay, such as when we use the OpenAI, ChatGPT, and all different models that they provide. Okay. Now, the other thing also behind all of that is that when we are using Ollama models, these are ours, meaning that we download them internally in our local machine, and we have a lot of control. Okay? So that is the beauty of, or in this case, that is the problem that this solved. But that's not the only problem that is being solved. The other one is that privacy. So in this case here, when we run our own models locally, we are making sure that our data doesn't need to be sent to external servers. Because remember, when we're passing data through a large language model, using ChatGPT in this case, or OpenAI models and so forth, we literally are passing through or sending our private data to different servers that we don't know what will happen out there. So this way we have some security issues, but with Ollama, that goes away because we have this enhanced privacy and security. This is very important because imagine that you have an application that needs to be dealing with sensitive information. Then it's important to have your own models, your own LLM, so that you have this contained environment where you're not sending out that sensitive information. When you want to set up large language models, it is cumbersome, which means it's technically challenging and often requiring knowledge of machine learning, frameworks, and also hardware configurations. But as you will see with Ollama, all of that is simplified. So this whole process is simplified by handling the heavy lifting for you. Also, most importantly, cost efficiency. Now we're going to be eliminating the need for cloud-based services, which means you're going to avoid this ongoing costs associated with API calls or server usage, because everything, remember, is going to be local. So once you have everything set up, you can run models without additional expenses. The other one is latency reduction. What that means is that local execution obviously reduces the latency inherent in network communications. So when we are communicating with something that is somewhere else through the network, of course, there is always a delay. Even if the network is really fast, there's always this latency, the delay, okay? But since everything is local, we don't have that problem, okay? Because we're not dealing with remote servers, which results in faster response times for interactive applications. And also, most importantly, we are able to customize our own models, because when we're running these models locally, it allows for greater flexibility in customizing or even fine-tuning those models to better suit specific needs without having these limitations imposed by third-party services. So these are some of the advantages we have by using Ollama models. So I know that we are eager to go ahead and start doing the hands-on, but let's continue here to talk about some key features of Ollama. Okay, so the first one is what we call the model management. This is a big one, which means that we are able to easily download and, if we want to, able to switch between different models or between different large language models. And that is the main point about Ollama, is that the idea is that we have this central place called Ollama as an open source, as a framework, as a tool that essentially allows us to manage all of the different models that we can use interchangeably. Okay. And the next one, of course, is we have this unified interface. What does that mean? Well, that means that we're able to interact with various models using one consistent set of commands, as you will see. And of course, we also have what we call extensibility. What that means? Well, that means we have this support for adding custom models and extensions if we need to. Obviously, we have what we call also performance optimizations, which means you're able to utilize your own hardware effectively, including GPU acceleration if available. Because remember, all Ollama allows us to do is to manage all these large language models that we can download locally. That is the key point here. And then we can do all sorts of things. With that, we have this performance that is optimized because everything is internal. it's locally, as well extensibility, because we can add different models and extensions as we see fit. And of course, we have this unified interface because we're able to interact with different models, but still using a very consistent set of commands, as you will see. But the main point here, of course, is that we have this model management in one place. We're able to easily download and switch between different large language models. Let's look at some use cases. Well, as you can see, you can imagine we have a lot of different use cases for Ollama. One of the first one is development and testing. So you can imagine that as a developer, you are able to look for different large language models and switch them to test them out to see which one is going to perform better depending on what you want done. So that's huge, right? So this is a deal, of course, for developers who are looking for ways to test applications that integrate large language models without having to set up different environments and all that complexity. So also for education and research, what that means is that Ollama makes it really easy as a platform for learning and experimentation without the barriers of entry that are associated with cloud services. So it's really easy. Just download certain kinds of large language models and you can go ahead and do testing and do some research and so forth. And we talked about this secure applications. The beauty of having Ollama is that it provides this managed or this management platform of all of these different large language models, which means it's suitable for industries like healthcare or finance, where data privacy is very critical because everything is your own. You download the large language models on your own machines. So in conclusion, Ollama addresses these challenges of accessibility, privacy, and of course, as we talked about, cost in the realm of large language models. So by enabling local execution, which is exactly what we do with Ollama, it democratizes the use of advanced AI technologies, making them more accessible and practical for a wide range of applications, which is exactly what you would want. Okay, so now it's time for us to look into setting up Ollama locally. And what we'll do, we're going to go through the installation process and do the setup. Before we do setup, there's some things I need to let you know. Most of you should be okay. There are some system requirements we need to be aware of. First of all, Ollama supports Mac, Linux, and Windows, and I'm sure other operating systems there as well, but these are the main ones. And also make sure that you have at least close to 10 gigabytes of free storage on your machine. This is very important because, as you will see, some of these models require a lot of space. And also processor. As long as you have a modern CPU processor, you should be fine, and most of you should have that in place. Okay, so just something to keep in mind. All right, let's go ahead and get started with installing and setting up Ollama. So if you go to ollama.com, OLLAM.com as such, this is what you are going to be able to see. It says here, get up and running with large language models. Now, because this is a moving target in technology, things may change a little bit or dramatically by the time you watch this video. Hopefully not. But the most important thing here to remember is that the idea is still the same. You will be able to download this tool and use that way, independent on how it looks. Okay, so should look the same, but you never know. And you can see here at the recording of this video, it says here Llama 3.2. This is the latest Llama 3.2 model that they provide. We need to download Ollama. How do we do this? Well, it's very simple. All you do, click here, download. Once you click that, this will take you to download Ollama page. Now you can see we have 3 different flavors. We have Mac OS, so the browser was able to pick up that I am on Mac and so offered Mac. If you're on Linux, of course, you'll have to click and look at this. So you'll have to install by taking this command and running on your terminal. If your Windows, of course, is also just like Mac, you have to download as an application and run it. Okay, whichever way, you have to download the Ollama zip file. So I'm on Mac, I'm going to click download. And then you can see that it is downloading here. So I'm going to wait for a second. All right, so it was downloaded, and let's go ahead and click and open real quick. So this is what you should see, a zip file, at least on Mac. All right, so I'm going to go ahead and double click, and it's going to unzip, and then it's going to look like this as an application. Okay, so what I will do, I'll just double click again, and it will install again as an application on my Mac. So I'm going to say open, that's fine. And then I'm going to move to applications, and there we go. So once we've done that, I'm going to show you real quick here. This is what I see. So I have now this window on Mac that allows us to go through the process. I'm going to say next and install the command line. I'm going to say, go ahead and say install. And I'm going to need to pass here my credentials. Say OK. So run your first model. So we're going to run this Ollama run Llama 3.2. Now, again, this number here may be different from when you're watching this. Doesn't matter. Just follow the instructions. So I'm going to say finish. So what happens now is going to go ahead in the back end, run the command, and everything is good. So it's going to install the Llama 3.2, which is a model. That's a large language model that's going to be installed with our installation so we can get started. And you can see once that happens that the Llama is running, because now we have this icon at the top that is showing there. This is Llama icon, and you can quit from here as well. Okay, next, what you can do is, let's go back to models. This page, this is where all the different models that Ollama has, this is where they are aggregated, and we can look into them and learn about them. You can see at the top we have Llama 3.2, which is the latest one, which is the one that was installed already locally in our machine. We'll come to this later and see more. Now, let's go ahead and click on this one so I can show you something real quick here. Okay, the beauty here is that when you click on any of these large language models, you will see essentially the same things. Okay, if we have these 3B, we'll talk about this later, and 1B, latest, and so forth. Okay, and then most importantly, we also have all of these things that we don't care about at this point. We have a README, we have the sizes to tell us exactly what they mean, what they're good at, this 3B default, for instance, and how to run it. So this is essentially what you have at the top here. So we're going to copy this and we're going to open a command line or a terminal. I have one open and I'm going to paste that. So what this does, well, it says Ollama run Llama 3.2. So what we're saying here, we're going to use Ollama as the tool, the framework, right, to run Llama 3.2, which incidentally, it's already installed on our machine, right? I'm going to just hit enter. And what we'll do is going to spin up the Llama 3.2 model for us, and then open this shell where we can start interacting with the model, just like that. Now, I need you to think, to go back to what we talked about, the beauty or the advantages of using Ollama is that Ollama has different models that we can use and install them internally, locally on our machine. And we can easily then, through Ollama, as this manager of this model, start interacting with different models. Right now, we are interacting, we're able to interacting through the shell here with Llama 3.2 model, which means I can ask questions like, how old is the universe? Look at that. And it gives me an answer. The thing to keep in mind is that Llama 3.2 tends to be a little bit verbose, and as you can see, it is quite verbose, but that's okay. I can say, in short, tell me how old is the universe. So you can actually direct it to tell you exactly what you need, right? It's kind of like prompting it a little bit. So the universe is approximately 13.8 billion years. All right. So I can also say, for instance, clear. See what's going to happen. Glad you could convey that information clearly. I guess I have to say something like this. Clear. It cleared the session. Okay. Now, I can continue here by saying, for instance, for help, I can say / I can put the exclamation point, or I can say help like this. So this will give me, it's actually exactly other commands that I can use. We have the set, show, load, save, and clear session, as we saw, as well as by to exit the shell. So let's go ahead and use this show here. Okay, I'm going to say / show what we want. What is that I want to show? I want to show info. So this will give us information about the model that we are looking at, which is the Llama 3.2. It says here, architecture is Llama. The parameters is 3.2b. We'll talk about that. And the context length is that, and embedding length, and so forth. And some other licensing information. So just like that, ladies and gentlemen, we're able to install Ollama. And of course, because Ollama itself is just a manager, we need to have the actual large language model. And that's easy to do by installing, in this case, Llama 3.2. We could have installed any other model, of course, but we start with that one when we're installing Ollama. All right, so now I can say another question. Tell me a short joke. Okay, here's one. Why couldn't the bicycle stand up by itself? Because it was too tired. Very funny. All right, and if I want to get out of this shell, I can say / by like this, and you can see we're no longer in our Llama 3 shell. So I can clear, and we're done. Okay, very good. So I hope this is a good introduction. There is a lot that's coming, and I hope this excites you because the power that we have right now is that all of this is locally. We've imported, we have downloaded the Ollama tool, in this case, manager, along with one model, which is Llama 3.2. Okay, make sure that you're able to do this, and I'll see you next. Now, to keep in mind that the whole idea of Ollama is that we have this place where we have many different models we can use interchangeably. We can just pick one and then drop it and then pick another one and test until we find something that works. So it is important to always look at these models page here so we can look at what's available. And most importantly, as you can see here, you can also go ahead and search or actually filter by featured, most popular, and or newest, and so forth. Okay, so newest here seems to be Nemotron. So keep in mind again that these will change depending on when you're watching this video. Okay, so maybe you're not going to see this as the newest. But the important thing is this is the place for you to come and look at what's going on. So as far as we're concerned right now, updated 3 weeks ago, we have the Llama 3.2. It is also important for us to have more information about those large language models because the idea is for us to be able to choose what works for what we're trying to accomplish. Okay, so let's click on Llama 3.2. So when you click on Llama 3.2 or on any large language model that is shown here, you're taken to this description page. Now there's a lot going on here. The important part here is that we understand at least the basics of what's happening. First of all, we see that is under tools 1B, 3B, which we'll talk about. But also we see that it was polled 1.1 million times, okay, which means this is essentially being used by many people. And then here we have these tags, 63 tags, but then we have here this drop-down list that tells us different things. First one, we have different flavors of this Llama 3.2. We have this 3B, which is the latest. That's the one we have. And then if we want a shorter, smaller one, is 1B. One important to keep in mind also is that depending on the flavor that we get here, right, you notice that also we have the sizes. So depending on the flavor that we have here, we can have different sizes. So this one, 3B, is 2.0 gigabytes. Okay, so it's not too bad. But 1B is 1.3 gigabyte. And the latest, of course, is 2 gigabyte, which is this one latest. Same thing, okay? And we've seen this before. We have this command that we're going to use to run, in this case, this particular model. Now, if you go down here, we have a README. It tells a little bit more about this model. It's important for us to read. And then we have the sizes. So 3B parameters, which is the default. This says here the 3B model outperforms the Gemma 2 2.6B and the Phi 3.5 meta models on tasks such as following instructions, summarization, prompt rewriting, tool use. But what does this really mean? So I want you to look at this as a guide because, again, we go back to the whole point of Ollama is that we have different models that we can use. And us as developers or as people who are wanting to use these models, is that we need to find something that works for us. This is why it's important for you to always think about testing different models until you find something that works for you. What works for me in a situation X, Y, and Z, it's not obviously going to be what's going to work for you in your own situation. So that is something to keep in mind, always. All right? So it tells us here the comparison that for 3B parameter, this size here, it's real good at following instructions, summarization, prompt rewriting, and tool use. So use tools or function calling and so forth. Now, when it comes to 1B parameter, this is a smaller version of 3.2. It says here the model is competitive with other 1 through 3B parameter models. Its use cases include personal information management, multilingual knowledge retrieval, rewriting tasks running locally on edge. Okay, so if you want to pull Llama 3.2 1B, then you would run this. So you can imagine if you want something that will be good for this use case, obviously you will use Llama 3.2 1B. And let's go ahead. I'm going to show you how to do this. So we can run Ollama run Llama 3.2 to pull down to get this Llama 3.2 1B. So I'm going to copy this, go back to our terminal, just paste that. Actually, I should copy the whole thing and paste it. So Ollama run Llama 3.2 1B. So this will download this particular subset of model, this model. So hit enter. You can see it's pulling down manifest, it's pulling everything in. What may take a little bit depending on this size. Remember, we're actually downloading locally, so that means it will take up some space. Very well. So now you can see that we have installed Llama 3 1B. So if I were to go ahead and say / again, show info, you can see, voila, we're now using architecture Llama, of course, the same thing. Parameters is 1 to B, which is exactly different than the full-fledged Llama 3.2. So it's a little smaller, okay? And context length and all that information. So we can go and ask question, how old is the universe? Like this, and it's going to go ahead and do the same thing. But because we know from reading here, we know that this particular one here is really good at writing tasks running locally on edge, multilingual knowledge retrieval. So I can ask things like, as an example, how do you say hello, I am fine in Thai? Let's see. Okay, so it was really good. This is just a very simplistic test here. So again, you can see the things you can do. You can pull in different large language models to see what's going on. Now, the other thing I can do here, I can say, I'm going to just say bye, just to get out of here. And still here, I can say Ollama, and I can say list. So this command here is going to list all of the models that have been downloaded locally. Look at this. Now you can see we have this Llama 3.2 1B. This is the latest one. Okay, it says exactly when this was downloaded. And of course, I have a few others that I've downloaded a while ago. So Llama 3.2, latest, long time ago. I have this embedding large as well, which we'll talk about later. Very good. So here it shows everything that has been downloaded in terms of a list of all of the models. Let's look at parameters and do a quick deep dive so that we understand a little bit more about the information that comes with models. So we're going to learn what are parameters as well as what is it that they really mean. Right, so when we say show info, that command, we saw this. We have this model, architecture, Llama parameters, of course, 3.2b, context length, embedding length, quantization, and so forth. So what do all of these mean? Let's start with the first one. So the first one is in this Llama architecture here. First of all, the architecture side of things, that means it was architected. It's a Llama large language model, Meta AI. That means they are the ones who created it, Meta, Facebook. And also that means that these models were designed with one thing in mind, which is efficiency. They were designed to be extremely efficient, which means they are strong when it comes to performing even at smaller scales compared, of course, to other large models out there. So they're very efficient and perform really well. Now, when we look at then the parameters side of things, it says here 3.2b, and we saw that sometimes it fluctuates to 1.2 or 0.3 or 1 and so forth, different numbers. These are the internal weights and biases that the model learns during training. But what they do really is that they determine essentially how the model processes input data and how it generates output, because that's the whole point. Okay. Now, when we say 3.2b, for instance, what does that mean? Well, that stands for 3.2 billion parameters. Now, you can imagine, even if you don't understand exactly what those means, that means if you have 3.2 billion parameters, in this case, these weights and biases, everything, neurons and nodes and everything, that means you have a lot inside of this neural network, which means there's a lot of information that can be passed around, the relationships and so forth, which in terms mean that this model, the more billions or the more parameters it has, which means that's more connections and more interactivity inside, that means the more accurate it is when it comes to getting the results. Now, it's important to understand also that the number of parameters does reflect the complexity and the capacity of the model as explained. But there's also what we call a trade-off, which means that more parameters can improve performance, of course, but it will require more computational resources. So if you have a large language model that is 3B or 5B or 7B or 8B, well, that means it's going to be amazing in terms of performance, but also means it is going to require a large amount of computational resources. So when we have something like 3.2b, this kind of strikes the balance between performance and resource consumption. So let's summarize this simply. When we talk about parameters, we talk about 3b or 2b or 10b or 7b and so forth. These are numbers inside a neural network that it adjusts to learn how to turn inputs into correct outputs. So the larger number, the more, the better in this case. But we have drawbacks in that you also need a lot of computational resources to run it. So next we have the context length. So this number refers to the maximum number of tokens, which essentially are pieces of text that the large language model can ingest in a single input. So when we have something like 131,072, this is an exceptionally long context length. What that means is that it can handle very long documents, capturing dependencies across large spans of text, which is really good. That means you can take big, large books and lengthy articles and extensive conversations, and it can deal with it with no problem. When we talk about the embedding length, we're talking about the size of the vector representation for each token in the input text. So when we say 3072, what we're saying is that we have 3072 dimensions in the embedding space. So the larger number, again, the more dimensions we have, which means the more relations you're going to have in this vector space. So what does that mean? Well, that means that we have what we call the semantic richness, which means higher dimensional embeddings can obviously capture more nuanced meanings and relationships between words. When it comes to a large language model, then that means this will reflect the model's ability to understand very complex language patterns. So the larger we have this high dimensional, the more the model is going to understand complex language patterns. Now, there are some implications again, is that we have this computational load. So larger embeddings increases, of course, the computational requirements. And also, if we have that, that's going to improve the model's ability to generate contextually relevant and coherent responses. Okay, and the last one we have here is quantization. Now, there's books and we can spend hours and hours talking about this, but in general, quantization essentially is a technique used to reduce the size of a neural network model by, in this case, reducing the precision of its weights. This number indicates that the model's weights are quantized to 4 bits. So translating, essentially we're just saying we now have a smaller model and faster processing and lower memory usage. So now we have a more efficient model. So going back to our Llama 3.2 model page here to see more information. Now you understand what 3B means, 1B means, and the implications and so forth. And one thing you will realize also is that at the bottom we have what we call benchmarks. Now, I don't really trust a lot of these benchmarks because anybody can inflate the benchmarks or deflate them to follow a certain agenda. But nonetheless, it's nice to look at and see the benchmark. But one thing I want to show you here is the implication of the sizes, the parameters. If I go back perhaps, and let's go back to models here real quick. And let's look for something different. Let's look for Llama 3.1. You can see with Llama 3.1, you even have 8B, 70B, 405B. Let's click on 405B. Well, let's look at this one. You can see that if we go to 405B, that's 229 gigabytes of space you have to have in your hard disk. That's a lot. And even if you're able to have that internally, locally, that means you also have to have the computational capacity for you to be able to run these models. So this is something to keep in mind. You could have the capacity of having 229 gigabytes locally, but will you have the capacity of the computational resources that are needed to run this? Now, keep in mind, as you learn now, this is probably one of the best models versions, right? Because it has everything. It's large, billions and billions of nodes and neurons and everything. Okay, that's something to keep in mind. And so for things that most of us are able to do, want to do, 8B, even 70B should be totally fine. Okay? Just something to keep in mind. And as you go through each one of these different models, they have different things. Okay, you can see, of course, we have more information here, 405B, 7B, 8B, and so forth, as we talked about. And they tell us the evaluation and what they're good at, when should you use it, and all these different informations, as well as human evaluation, as you see here. So this is something to always go ahead and read, and perhaps go to some links here to read more about it. Now, I want you to always have this inquisitive mindset whenever you're looking for models so that you know exactly what you're getting and contracts that with what you want to accomplish. That's how you need to go by when it comes to using Ollama and different models here. It's not just one model fits all. That's not the idea. The idea is that you find something that will work for you. Okay, so models are real fun, and you can always go ahead and test them out. Now let's go ahead and run through some commands with Ollama. That way we are well situated and we understand how to use some of the most important commands. Okay, so let's go ahead and get started. So we know that we always start with Ollama. We can say Ollama list. This will list all of the installed models internally, locally. So you can see we have 32B, 32:1B here. It's the size and when it was modified. And we have other ones that I have here. In your case, you should probably, most likely, just have one. Let's say I want to delete or remove a model. I can say Ollama remove. Also, I can say Ollama help, which is going to give me some of the commands that I can use. We have serve, we have create, show, run, stop, pull, push, list we've seen before, PS, and RM for remove. So let's start with, I'm going to go back, say Ollama list to show the list of all of the models that we have here. Let's say I want to delete this one here. So I'm going to copy that and I'm going to say clear Ollama RM to remove and pass in the model name. Hit enter and it's going to delete that model. Now if I go ahead and say Ollama list again, we should see that we no longer have that model. Very good. And if you want to delete this other one here, you can also do like that. Now if we want to go ahead and pull in a new run, we can say Ollama and I'm going to say pull and the name of the model as we've seen before. So again, we can go back to our models website, all right, Ollama library models, and let's say we want to get Gemma. Okay. So I go back here, you can see models, all these models. Let's say I want to get something different. Let's say we want this code Gemma. If you click here, you can see that we have different flavors. Let's say I want to be smaller, so you can see we can run this one here. I can either run all of this or I can just pull first this one and then run it. Okay, so two ways to do the same thing. So I can say Ollama pull like that. It's going to go ahead and pull our model. Now remember, this is 1.6 gigabytes and it may take a little bit. Okay, so once that is done, I can say Ollama list. We should see that we have code Gemma. So I can now run it, right? So let's go ahead, say Ollama run code Gemma. So it's going to now run code Gemma so we can interact with it. I go back here, you can say that code Gemma is a collection of powerful, lightweight models that can perform a variety of coding tasks like fill in the middle, code completion, code generation, and so forth. So let's see, we can test it out, right? You can see if this works. So I can say, for instance, write me a Python function that returns hello world. Okay, there we go. You can see define function, your name, return hello world, your name, and there we go. All right, very good. So you can see that we're able to, of course, download a new model and test it out. So what I can do again, I can just say /by to get out of here. And then I can say Ollama list to see that, and I can copy this and remove it. So I'm going to say Ollama RM to remove that, and it's deleted. And Ollama list again, you can see that we no longer have Gemma. Okay, so back to our models here. I can go ahead and look at models and imagine that we want to find a model that deals with images or that is able to read an image and tell us what's going on. There's a model called Llava. So Llava is a novel end-to-end trained large multimodal that combines a vision encoder and Vicuna for general purpose visual and language understanding. So this is a good candidate for what we call a multimodal model, which means is that it's able to deal with images as well as text and so forth and other types. Okay, so we have just this one, and then we have this Llava Llama 3. So depending on the situation, we can read more to figure out which one is the one we should probably look into. So let's click on this Llava. And as you can see, we have 7B, 13B, and 34B. So you know which one we're going to be using. So I'm going to go ahead and get at least the 7B, which is this one here, latest or 7B, doesn't matter. It's about 4.7 gigabytes. Okay, so let's go ahead and pull this one in. I'm going to copy that. And let's go ahead and just paste it all in and get our Llava 7B. All right, so after a little while, you can see that we downloaded a few things here, but most importantly, we have this 4.1 gigabytes. So we have now our model is running, and you can see we have our shell. I'm going to just say, what is your name? See what's going to say. I don't have a name. Of course, it's just a large language model. Okay, so now let's see what we can do. One thing I'm going to do actually is I'm going to move over to a code editor, VS Code, to make this simple. Okay, so I'm just going to say bye for now. And then I'm going to open up here to see VS Code. So I have this flower_1 PNG. We're going to use this with, of course, our Llava model to see if it can read this image and tell us what it's all about. Okay, so let me go ahead and open the terminal here real quick. And so what I'm going to do first, let's go ahead and say Ollama. I'm going to run Llava 7B. Okay, now it's running. Very good. So what I'm going to do now is I'm going to say what is in this image, and then I'm just going to pass the image name, which is flower, 1.png. Let's see what's going to happen. So now it's going to think and tell us exactly what it sees. So the image shows a bunch of small purple white flowers with yellow centers, which appears to be a type of pansy. They're growing in what seems like soil or a potting medium, surrounded by what looks like green foliage. So that's pretty good, right? For if you go back here and look, yeah, it looks exactly, that's exactly what it's describing, which is really, really awesome. Now let's test something here. I'm going to test to see if this model has this history capability, meaning it's able to save the conversation for context. I'm going to say, and now write me a short poem about that. Let's see what's going to happen. Ah, there we go. So it was able to look at that. A purple and white with yellow hearts defined. They add a touch of beauty to the world around. A little patch and so forth. So it knows, now we know through our testing, that this model is able to save the context, the history of the things that we've been asking, the context of our conversation. Tell me more about those flowers. Let's see what's going to say. Okay, there we go. It knows exactly what flowers we're talking about, which is what we had here. Okay, I can ask, can you tell me where they grow best? And keep in mind again, this is all local large language model that we're running. We don't have to go and send requests to a network somewhere. It's all local. Very good. So pansies are native to the Mediterranean region and all that great stuff. Very good. So we see that it is indeed working. So we're able to pull in a new large language model, in this case, Llava, which is a multimodal model, which allows us to deal with text as well with images and so forth. And we ask it to tell us what it sees, right, in this image here. And it was able to give us the description of the image. And we ask some follow-up questions about that image, and it works. So I've changed to Ollama, run Llama 3.2 model right now. So I'm going to do it again. You can see since it's loaded, then we can see that we are able to go to the shell. So what I want to be able to do is show you that you can also do many different things here, right? So because we are running on a large language model, it's a model that does a lot of things. I can perhaps say I have a sentence that I'm not sure the sentiment of that sentence, right? I can say, tell me what is the sentiment of the following sentence. I'm not willing to pay you back. Let's see what's going to happen. Okay. Again, it's very verbose, which is okay, but essentially says that the sentiment of the sentence, I am not willing to pay you back, is negative and confrontational. It implies that the speaker is unwilling or unable to repay a debt. All right, so this is really good. Now, one thing we can do, I can also say, can you please be less verbose? Okay, there we go. So the beauty here is that we are talking or you're interacting with a large language model, and you can actually prompt it to do what you want it to do. In this case, I told it to always be prompt to always be less verbose, at least in this case. And you can see, it says the sentiment of I am not willing to pay you back is negative and confrontational. It implies resentment, defensiveness, and obligation aversion. Okay. Now, the beauty here is also we can modify, or in this case, customize our model, because we can actually add certain pieces of metadata to the model that cater to what we want it to be like. What I mean by that is that we can actually create a file here, right click, I'm going to click here, and this is what we call a model file. So it has to be something like this, model file, no extension whatsoever. And inside of this file, this is where we are going to add a few lines of text code, essentially. So at the top here, I'm going to say, all caps, say from, because we are modifying it from a base model. It's going to be from Llama 3.2 in this case. If you have something different, you add that. And then here is where we're going to set a few things. So we can set a lot of things, but now I'm going to show you how to set, in this case, the temperature. What is a temperature? Temperature is what allows the model to be more creative or more direct and matter of fact. So the higher the number, in this case from 0 to 1, the higher the number, closer to 1, the more elaborate, the more creative the model is going to be. Okay, so I can change to 0.3, for instance, if I want it to be less creative. And then I can add, for instance, the system message. So this is just the prompt, right, that it needs to know of. So in this case here, put that into, let's say, triple quotes like that to say inside here we can put text. A very smart assistant who answers questions succinctly and informatively. Okay? Something like this. So this is our model file, which is going to allow us to modify or customize our model. Okay? So we can add more parameters here, more things to aid our model, but this is okay for now. So how do we do this now to make it so that our model indeed will comply with what we put together here in this model file? Well, it's very simple. All we have to do now, I'm going to, let's go say bye real quick here. All we have to do now is we need to use the create command from Ollama to create some sort of a new version of our model, which is going to be specified by this model file. Very easy, really. So I'm going to say Ollama and then say create, and I can give it a name. Just say James, okay, whatever you want. And then we're going to say F to say to the file. It's going to be under the model file. Notice the model file is actually at the same level here, so I can just go ahead and that. So if I hit enter, what's going to happen now? Let's say enter. Okay, so it says success. You can see that it went ahead and transferred model data, so using the layers and everything in the background. And so now if I say, for instance, list, you can see that we have this James. So it really created a replica of the main model. And now this is going to be different from the Llama 3.2, right? Because it will have a little bit more of a modified, customized piece to it. Very good. So now I can use Mario, or James I should say, to ask questions. So look, now I can say Ollama first run James. Look at that. And we should run James. How beautiful is that? So look at what will happen. I can say, what is your name? Look what's going to happen. My name is James. And look how succinct it is. It goes straight to answer what needs to be answered. Are you smart? Let's see. I designed to process and provide accurate information quickly and efficiently, making me highly knowledgeable on a wide range of topics. And all of that comes from this, because we said that your assistant, that was very smart, answer questions succinctly and informatively. Very good, very good. You can see the power of things you can do, right? So now I can ask questions. Let's see. Let's say, tell me about the oceans. Let's see. Okay, so this is pretty good because it's such an open-ended question. It went ahead, there are 5 oceans, gives me all that information. Oceans play a crucial role in regulating the Earth's climate, weather patterns, and ecosystems. They also provide all of this information here. Okay, so it is to the point. That's pretty good. This was just an example to show you the things you can do. You can actually modify, customize your model to be and do certain things that you wanted to do. This, of course, was very, very simplistic, but you can see for the system here, we can prompt it even better with more complex information and change temperature and all these different things. let's go ahead and just say bye. And because we're done, let's go ahead and get rid of it so that we save some space. So Ollama RM James. Okay, so for Ollama list, we should not see James. And while I'm here, let me go ahead and actually get rid of some of these as well so that we have more space. Okay, very good. So far, we've been using the CLI, the command line interface with Ollama, which is attached with Ollama that governs everything in the backend. But we can also use the REST API. In fact, most of the things that we're going to be using later are based on the REST API, which means there is an endpoint that we can hit and run, in this case, the models. So how does that work? One thing to keep in mind is that in the backend, as you see, well, you can't quite see here, but at the top in my bar here, I do have this, well, you probably see this quit Ollama, but there is this Ollama that is running in the backend. So that means in the background, it's running, which means we're able to do all sort of things that we're doing, right? The Ollama application per se, it's running. But it's actually being served at an endpoint locally. And all of that is being served at localhost 11434. What does that mean? Well, that means then we can generate a response using the Ollama REST API because it has it attached to it and it's running in the backend, in the background. Okay. So to do so, it's very simple. All you have to do, you have access to all of this. We can curl something like this. So in this case, you can see I say curl, and this is the endpoint. So localhost 11434 API generate, and then -d. And then we pass the payload here. So here we're saying the model is going to be Llama 3.2, right? And the prompt we're passing along it, why is the sky blue? So if I were to run this or hit enter, what will happen is it's going to hit that endpoint, and of course it's going to show me this. Now, this is not very helpful, mainly because it just shows a lot of gibberish and there is this stream that's happening. But if you look closely, you can see that every time this run Streamlit, it's going to show a certain word in the response. So combining all these words will be the response. So that means then when we write the actual REST API payload, we need to also add something else to it to tell it that we don't want it to stream as it is right now, so that we just get the result. What that means, now I can, let me go back down, let's clear. So now what we need to pass is this here that says stream false. So say we don't want it to stream, just give us the response. If you hit enter, you can see it will take a few moments, and then voila, we have this model, everything, all the metadata about the model that we're using. In this case, I said, tell me a fun fact about Portugal, and then says here is one response. Did you know that the town of Óbidos in Portugal is often called the fairy tale town due to its medieval architecture and picturesque streets, right? And gives it some other information, right? So that is a difference here. If we put stream false, then we get that. If this is not there, it assumes that stream is true. That's why we get what you saw earlier. Now, in this case, you can see the endpoint is generate. Now, we can also get the chat with the model, the chat endpoint. Okay. So generate, the difference here, generate, it just goes ahead and predicts what needs to happen. As you see, it just gives us the result. But we can also pass in the chat endpoint. So let me go ahead and clear. To do so, I have that. You have access to all of this anyway, so no worries. And there we go. We'll do the same thing, curl. Now the endpoint here is API /chat and then -d. And then we pass here the payload. So we pass the model, the messages, plural. That's why we have here a list. Okay, so we pass the role, it's going to be user, and the content is going to say, tell me a fun fact about Mozambique. Let's go ahead and run this. So there we go. And now this is a different endpoint. It gives us here's one fun fact about the Gorongosa Peninsula, which has one of the largest coral in the world. I think this is actually not correct. They have to remember that sometimes these large language models are not always correct. So there's no such thing as Gorongosa Peninsula. I know this because I'm from there. But anyway, you can see that it's giving us some results. Large language models are not always correct. So as always, we can also pass more information or more specification to our endpoint in our payload. So imagine that we want to, for instance, we want to request a JSON mode. We can do so by requesting it, by adding JSON, right? So you can see here, we are hitting the generated API, and we have the same thing, model, prompt. Now, here, we even said in our prompt, make sure that we want to get the response as JSON, but also we want to say here as one of the parameters that format, it has to be JSON. So to make sure that indeed the large language model adheres to this. Okay, let's go ahead and run. And you can see it doesn't look that great, but we want to believe that this is actually a JSON, okay, that is coming in. So you can see the curly braces are opening in the model, and then Llama 3 created and all that information. And we should have an actual JSON. But you can see response, day, morning, sky color, and so forth. The beauty here is that if you go to this link here, GitHub Ollama, Docs API, endpoints, or so many other endpoints we can go ahead and hit using the REST API. Okay? You can always come here and look at some of them. We can do essentially the same thing we were able to do in our CLI. That's the whole point. We can do that using the REST API. For instance, we can copy a model, show model information. You've seen that before. Okay, you can just curl and then do that. So I'm not going to do that. You can do that yourself. And then this is the result that you get. So all of these things that we've done before, you're going to be able to do them as well using the endpoint API, the REST API endpoints. We've learned a lot so far. There are a lot of things that we've learned about the CLI. We learned how to use the CLI, of course, which is attached to Ollama to do all sort of things, to pull in different models, to run them, to remove them, to even modify the model, or in this case, customize the model by creating the model file, and then use that to create some sort of a copy or a modified version, customized version of that model, which is very handy, as you see, for use cases that you might have. Okay, so a lot that I've thrown at you. I hope this is making sense. I hope you are practicing and seeing the power. And most importantly here, remember, is that all of that is local. You're not having to do anything, passing something to the network to get anything back in that way, which means it's free. You're just using your own resources, which is the power of Ollama. So as a quick full summary here, Ollama, as we know, is a platform that allows you to run large language models locally, which is really awesome. The great thing is that it supports various models tailored for different tasks, including text generation, code generation, and multimodal applications. So essentially, Ollama models support these tasks here. Text generation, such as Llama 3, X, could be 3.2, 3.10, or 3.11, depends, Mistral, and so many others. We have also code generation. One of the example was Code Llama, okay, and multimodal application, in this case, text and images. And we saw, in this case, was Llava, the Llava model. Now, this is just to show you the breadth of things or models that Ollama provides. Okay, so again, your job is really to figure out what models is going to give you the best results for your use case. Okay, so keep in mind that you always have to test, figure out which one will work for you. Right, so to create large language model applications using Ollama, we saw that, first of all, we can use large language models that come with Ollama because Ollama hosts, per se, all of these different large language models we can use. Now, we also learned that there are different ways to interact with Ollama and its models. So we saw that the main way is through the CLI, the command line interface. So it's easy, straightforward, and that's what we've been looking into. And then the second way would be, in this case, to use UI-based interface, which we're going to look into next. So essentially have a user interface where the back end, we can put or apply a model, Ollama model, and then we have a nice user interface that users or yourself can use to interact with the model. Now, we've just finished looking at the REST API. So this is the base of essentially everything else we're going to be doing after the next UI-based interface way of interacting with the models. Okay, so essentially we're able to use REST API, curl, and then hit the endpoint and get information that way about generating text, or in this case, deleting things, deleting models, or looking up everything related to our models. So essentially the same things that we're able to do using the CLI, we have a way of doing that using the API, the REST API. And later, we'll see, we're going to use Ollama Python library. Now, this is where we're going to be able to then use the tools in Python in code, because now we have more customization, more freedom per se, to start building the actual large language models applications that we so want to do. Okay? Okay, so now let's go ahead and look at the UI-based interface. So if you go to Msty, that app, M-S-T-Y, that app as you see here, this is what you will see. So you can read about it. It says Llama 3.2, Vapor Mode, all this great stuff. It says the easiest way to use local and online AI models. So without Msty, painful setup, endless configurations, confusing UI, Docker, and all these other things. With Msty, one app, one click setup, no Docker, no terminal, offline and private, unique and powerful feature. So that's the reason why I chose this. Of course, you can choose any other that you might find out there that I mentioned. So this is what I'm going to be using. And you can see there's a lot of logos here saying that it works with Meta stuff, with Chat, OpenAI, and many, many others. So it's really good. So you can see Windows, Mac, and Linux, and they do have a user interface. So you can see exactly how it will look like. So essentially, it's going to be like having a ChatGPT, but now we are running our own models. So click here, and I am on Mac. Of course, I'm going to go that way. If you're on Windows, you have the option to do the 64 or 64 CPU only, AMD or NVIDIA. If you're on Mac, you have Apple Silicon or Intel chip. If you're Linux, of course, you have these flavors as well. So pick the one that works best for you. So I'm on Mac. I'm going to go to Apple Silicon like that. So it's going to go ahead and download. Okay, so it's now downloaded. Let's go ahead and open it. And I'm going to double click to start the installation. So I'm going to go ahead and drop it there. Very good. And let me go ahead and open it real quick. Okay, so I'm going to say open. All right, and there you have it. Now, once you open it, this should happen. And the beauty here is that you can see how would you like to get started. You can say set up locally AI, add remote models provided, and so forth. But if you look down here, look at this. Got Ollama, get started quickly using Ollama models. All right, and even found it under users, me, Ollama, and all the models. They found it locally because it detected that we have Ollama installed on our machine. So I'm going to go ahead and say continue down here. Okay, that's it. Just one click and we are done. And you can see here at the bottom here, make sure I can make this larger. Yeah, I can make this larger. That's very good. Okay, at the bottom here, you can click, maybe smaller. You can click and see we have different levels or different models. We have Llava 7b, which you remember, and I have Llama 3.2. All right, because those are the ones that we have installed, or at least I have installed locally. If you have more than one, then you're going to see all of them show here. And this is beautiful because we didn't have to do anything. Just one click, indeed, like they promised, and we are there. So let me choose the Llama 3.2. And the moment you do that, that's it. And you can just start chatting just like that. I'm going to say, how old are you? Just silly to see what's going to say. So this is being powered again by our own model. So I was released to the public in 2023. Very good. Can you tell me a funny short story? And just like that, look how fast this is. One day, a man walked into the library and asked the librarian, "Do you have any books on Pavlov's dogs and Schrodinger cats?" Schrodinger, I think that's what you say. The librarian replied, "It rings a bell, but I'm not sure if it's here or not." Okay, that's very cool. So we have that. So you can start talking, you can start chatting with this large language model. And if I wanted to, I can also go and attach a document. Let's click here. And I'm going to add one image that we've seen before. Drop it there. Now image is attached. Let me go back here. And I can ask, tell me about the image. Now, here's the thing. The reason why it's saying this is because the model doesn't, because we're using Llama 3.2, it doesn't really know how to deal with the images. However, if I change here, go to Llava 7 and ask the same question, tell me about the image. Aha. And now, because Llava is a multimodal model, it will know how to answer questions about the image. There we go. Now it's working. The image shows 2 purple flowers with yellow centers. Okay, very good. So it is describing. It took a little bit of doing here. Perhaps I should have reset everything, but it's okay. You can see that now it is actually working because we're using Llava 7 and it will tell me exactly what it sees. Now I can change to Llama 2 or 3.1. And if I say, tell me about the image, it's going to give me some issues, of course. Okay, very good. So it can't do that. But the other thing I can do here, I can also add, let me just delete this, I'm going to add a document. Let's say, for instance, I'm going to add this document that we've seen before, which is the BOI PDF. There we go. I'm going to say, can you tell me about the PDF file? Okay. So now I have some issues here. The best way to do this is you go to attach knowledge stacks. So click here and I'm going to say add your first knowledge stack. So I'm going to say my tester. And the thing is, because we are now invoking or want to create a RAG system, we need to have an embedding model so that it can create those embeddings of the PDF file of the document. That way it can be saved and then the large language model is able to converse that way. Okay, so we're going to just use whatever they give us, mnemonic embedding text. I'm going to add that. It's very good. And at this point, let's go ahead and add an actual file. So I'm going to go ahead and drop it again. In this case here, just drop it like that. All right. So once you do that, you have to hit compose so that it's able to pick it up, do all the things it needs to do to actually get information from our file. Okay, embeddings and everything. Say compose. So it's composing. Okay, knowledge stack saved and composed successfully. You can now use it for chatting. Very good. So let me get out of here and I'm going to go here. So click again here. And what I want to do here is I want to be able to say, click on my tester, because this is my knowledge base I want to include in my chat here. So make sure you click that. And that will, what that will do is will let this know that indeed we have included that knowledge base, which includes all the information about our PDF file. So say, give me a summary of the PDF file. Okay, let's says there's no PDF file mentioned in our conversation so far. The text we discussed earlier was from beneficial ownership and everything. So it took a little bit because I'm asking PDF. It doesn't really know about the PDF because all of that information was actually transformed into text and embeddings and everything for the large language model. So I just can say, give me a summary of the document. Okay, there we go. So it says the document provides instruction on how to fill out certain items, including identifying documents issues, company's image and everything. And it is indeed beneficial ownership for all of that. So we've seen this before. I can keep asking, what are the penalties for not filing. And there you go. It gives me exactly the penalty and everything that will happen if I don't file, right? Or I can just say, give me the penalties. Maybe that's a better question, perhaps. Okay, that's better because now it's giving me exactly what I need. Okay, based on the text from beneficial ownership information, blah, 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 and everything is there. Failure to comply with beneficial ownership reporting requirements, civil penalty 10,000, fines up to 500,000, and so forth. Okay, what are the deadlines for filing? Okay, so you can see that this is working. We're able to converse with our data, our own document. Now, the beauty here, if you haven't realized yet, is that all of this again is internal. It's our own large language models. We can, of course, go and spin out a different large language model, okay, adding your provider and so forth, and we can use interchangeably as you see here. And we passed in a knowledge base, which means we said, here are some documents, in this case, which is one document, and use that to create a knowledge base, so a RAG system essentially, and so that we can chat and ask questions about that knowledge base. Okay, and just like ChatGPT, we can go ahead and create a new chat. We can do all sort of things as you see here. The point is not for me to go through Msty thoroughly. The point is to show you what's possible to create a user interface or to use a user interface that is guided or is being fueled by our own Ollama model. How cool is that? So what I want you to do is to play around with this, and you can see it's just to show you how amazing this is, because we have our own box that we can pass in sensitive documents and all those things without worrying about prices, having to call an API, anything external, put this in a cloud base, or having to pay for usage. So it's all here and we can use as we see fit. So we're able to see all of the ways in which we can interact with Ollama and its models. So we looked at CLI, command line interface, and we saw that it's really easy because it's the fastest access to our models. It's very easy, but as you know, it's not scalable in the sense that you're not going to build a full-fledged application using that. And then we went and looked at the API, the REST API, which is essentially the same, but now we have a different backdoor per se. We're using REST API to pass in certain payloads and get information. So we're doing the same thing that we can do with CLI, hitting the same functions per se, but now we're using different endpoints with the REST API. And we just finished looking at the UI-based interface. So this is way easier for us to be able to have a UI-based interface, an actual interface such as ChatGPT. That way we're able to ask questions, change manually, quickly, different models that we may have, and start chatting with our models. So it's really, really easy to put together or to have that working using the Msty that app. And of course, there are different different tools out there that you can use that will do the same thing, right? That would give you this UI based interface. So I chose Msty because it's just easy, as you saw, to install and get started. So it wasn't about how to use these tools, but it was about to give you the knowledge and tools that you can then use on your own and explore more. So now we're going to go to the fun part, which is we're going to use now sort of a backend combination of the API, REST API, through the Python library, the Ollama Python library. Because truth be told, we want to be able to create local large language model applications using Ollama models. And so for that, we need a way for us to be able to use Python, this code, in this case code, or any other language, but in this case it's going to be Python, to be able to take advantage of these models that Ollama provides. And so that's what we're going to be doing next, which is we're going to get started with Ollama Python library so we can use code to interact with Ollama models. All right, so I have this folder here we've seen before called Ollama. Got a few things here. let's get started here simply by using the Ollama library. But actually, I'm going to do the hard way first to show you that we can actually use code to get to the endpoint, just like what we saw with the RESTful API. So real quick, so we can see what's going on. So let me go ahead and create a new file here. So we're going to have access to all of this code, so no worry. So I'm going to say start one.p1 or py. Okay. And so what we'll do here first actually is I'm going to go ahead and make sure that we have an actual virtual environment for our Python project. So I'm going to say Python 3, okay, like that. So we should have a virtual environment there. That's very good. And let's go ahead and activate it. So source PNV. If you're on Windows, of course, there's a different way to do this. Activate, and voila. So now we have our virtual environment active, I should say. Very good. So what is the first thing we're going to do? Well, first of all, I'm going to go and import, say, pip install. I'm going to install requests real fast here. So we have that. Okay, very good, because we're going to use that to do what we are looking for it to do. All right. So I'm going to go ahead and import requests. So we have that. And also I'm going to import JSON. So we have that as well. Okay, so I'm going to create a URL here, which is going to be the URL where is the endpoint. It's going to be HTTP for our local host here. So it's not going to be that. It is 11434. And in this case, I want to go to the generate endpoint like this. Okay. And for that, remember, we need to pass some payload data when we pass along. So I'm going to say data, just create a little dictionary here. And for our dictionary, I'm going to pass the model that we need. It's not going to be GPT-3 or GPT-2. We're going to call this Llama. It's going to be Llama 3.2. And make sure that Llama is running for this to work always. And then I'm going to pass the prompt. I'm going to pass something that says, tell me a short story and make it funny, like that. Okay. So there we go. This is our payload that we're going to pass along using the REST API. So I'm going to send the request. So I'm going to say response, pass in the request, that post, pass in the URL and JSON. And what I want to do here is I want to say stream to true, to say I want this to be streamed. Okay, as you will see in a little bit. Okay, maybe this a little bit smaller so you can see everything. All right. Okay, so then let's go ahead and check the response first. So I'm going to say check the response status. So it's going to say if response status is as you see there. I already have all of this code, so I'm not going to bore you with all of the intricacies. I'm going to put it all there. Okay, so what we're doing now is that we're going to check if response code is 200, which means all is good. And then we're going to go ahead and start generating things. So we're going to go and iterate over the streaming response because we said the streaming to true as it comes, the response that comes in. Okay. And so what we're doing here, we're decoding the line and parsing everything until we actually print the generated text as we go through. Very good. So let's go ahead and see if this works. I'm going to go ahead and run this. Make sure that, of course, the Ollama icon is running, is out there. Otherwise, this is not going to work. So let's go ahead and run. Let's run this. Looks like I'm having issues. Right. So I'm needs to pass the API like that. Okay, my bad. That was my problem. Let's go ahead and give it a try again. Okay, and there you go. You can see that is indeed working, and it's really, really fast, as you see here. Generated text. Here's a short, silly story for you. Once upon a time, there was a chicken, blah, 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 and there you have it. All right. Very good. So this is indeed working. We're able to use code to actually interact with our Llama 3.2 model locally. right? Albeit we are not using the Ollama Python library, but you can see that this is actually working. Go ahead and play around with this, and I'll see you next. All right, so this was really nice. We're able to use the REST API in code here, the RESTful API, I should say, Ollama RESTful API in code to interact with Llama 3.2. This is fine, but now I'm going to show you how to use the Ollama library, the Ollama Python library, so we can go straight into code. We don't have to hit these. We don't have to explicitly hit these endpoints. All right, let me go ahead and create a new file here. Let's call this start2.py. Remember, you will have access to all this code, so do not worry. Okay, so the first thing we need to do here, of course, is to make sure that we import or we get the right dependency. So we're going to say pip install. We need to install Ollama as such. Very simple. And there we go. Now, once we have Ollama, we can start working, right? So first, let's go ahead and import Ollama. There we go. And real fast here, I'm going to show you how simple this is. So the same thing we did before with the CLI and even with the REST API, we can do the same thing here using this dependency, right? Using this SDK per se. So now I can say put inside of a response, and I'm going to say Ollama, and I can say list. So this function here, as the name implies, is going to list. It should list all of the, you guessed it, all of the things that we have. In this case, all of the models. So let's go ahead and save and give it a quick run. So real quick. Okay, I ran, and you can see that we have this JSON that comes up. It says Llama 7, our name, Llava 7, and that is the model, and I should have, gives all that information, and I should also have the Llama 3.2 and some other things. All right, this is very cool, very good. All right, very good. So you can imagine we can say Ollama list. We can also say Ollama, let's say chat response, client, create and delete, embed, and all these are different things, right? So that's very, very exciting. I just want to show you that. I'm going to just comment that out so we don't have a lot of things here. All right, so let's go ahead and hit the chat endpoint, or in this case, the chat API. Well, as you know, it's very simple. So let's go ahead and get started here. All right, so I'm going to say res. You can put anywhere. Ollama chat. So Ollama.chat. And then I'm going to pass a few things. And you can see that if you have over, it says it expects at least to have the model name. So the model, I'm going to say Llama 3.2. Okay, just add the one that you have. And then here, because it's chat, I'm going to pass messages. Okay, so this comes as a list. And I'm going to pass the role as a user. And the content is going to say something. I can say something different, that perhaps, why is this sky blue? Something like this. Okay, so now I can actually print what comes back. In this case, from our chat, we pass the model and the messages. Could be more than one message. Okay, we can also say for our role here, another one that says, let me just put like that. I can say the context, pass all different things that I may want to pass. Okay, but so far, this is okay. Let's go ahead and see how this works. I'm going to go ahead and just run from here. Okay, took a little bit, and you can see we have the results. So you can see the model and everything, but most importantly, we have the content. It says content is the sky, appears, and everything. But to make it even better, I can just go ahead and get the content. So let's go to result. Let's say, I think I have to go to messages and then get the content like that. Okay, go ahead and run again. Not messages, message. Okay. All right, and there you go. So the sky appears blue because of phenomenon called scattering and all of that great stuff. So we have all the information here. Now you noticed before when we just look at showing the entire payload, it comes in with a lot of information about the model, when it was created, of course, the content, the role, and all that information. At the bottom, we have some other pieces of data, metadata. So done, true, total duration, how long it took, and load duration, prompt evaluation, and also evaluation count, prompt evaluation duration, all these little things that we may want to keep track of. All right, so just like that, ladies and gentlemen, we're able to use the chat endpoint here using the Ollama Python library. So go ahead and play around with this and see what it can do, because this is the beginning of a very exciting thing, I think. Now, one thing you can also do, you should know this, is that we can pass other things in our chat function here, right? See, we have model, messages, tools, stream. So we can say we want this to be streamed, and the format as well. Very cool. So what you can do, I'm going to give it an example here. For streaming, let me go ahead and comment this out. So we have that. For streaming, it's essentially the same thing. Notice I pass in messages, role user. Now I have a different question. Why is the ocean so salty? And I can say stream true because I want it to be streamed. When I do that, then whenever I want to print that out, I have to put that through a for loop or a loop of some sort. That way we can get all of these pieces that are being streamed so we can see them being flashed out in our command line. Okay, so let's go ahead and run real quick so you can see. Let's just run like this. Takes a second, and there you have it. Okay, so there we go. So if you want to have this capability of streaming and showing those messages as they come in, this is how you would do using code. All right, so go ahead and play around, perhaps add different messages or different questions here and see how this behaves. And what you can also do, you can use a different model, whichever model you may have running. Okay. So one thing to keep in mind is that all we've seen now, this Ollama Python library or SDK, I guess I could call that, is all based or designed around the Ollama REST API. So internally, when we call Ollama.chat internally, we're essentially doing what we did before I showed you here. So it's hitting this endpoint URL and passing in the API, in this case with chat or generate or create and so forth. It's just like an abstracted way of hitting this endpoint. So we don't have to explicitly do this. So I made sure to put it here so that you have that. Okay, now we can use another. Now we can also use the same. Now we can go and use a different function or endpoint, for instance, like generate. If we want to generate something, right? We can do that. What I mean by that is I can say, for instance, Ollama generate and pass that and pass that prompt. I can even pass all of that. I don't think I can. Okay, I don't need to pass any of that. So we can also just generate a response instead of chatting as such. So nothing new here. I'm just going to leave it as is so you can see. The other thing we can do is we can say, for instance, we can show by saying Ollama. Let's just print and say Ollama and then that show. And we want to show what? We want to show anything about Llama 3 like that, that 2. Okay, let's go ahead and see. And there you go. After a few moments, you can see it tells everything we need to know about our model. Okay, a lot of information, that's for sure. Okay, there we go. The next thing we can do is we can actually use the model file as we did before. but all in code to create a separate model that has specific instructions. So it's very simple. I have some parts of the code here. So we create, in this case, the model file. We don't have the actual model file, but we can put all in line as here, as you see here. And the other thing I can do is I can pass the temperature here. Let's go back to this one to see how you do that. Just copy this and pass temperature 0.1, for instance. And then all we need to do now that we have this information is, as we saw before, we are going to go ahead and create the actual model. So, and then we're going to pass the new name, know it all, and then pass the model file, which is this one here. So we can make this more robust if we want. For instance, we can say, you are very succinct and informative, something like that. All right. Okay, so now that we have created our new know-it-all, so we can go ahead and generate something, right? Use the generate message or generate function. So I'm going to put into a variable. So Ollama generate, and I'm going to pass the model that I'm going to be using. Yes, it's going to be know-it-all, this one here, same name, and the prompt there. So I can just say, for instance, sure, that's fine. Okay. And we can go ahead and print the result. I need to go into response. That's how it comes as. Okay. And there you have it. So let's go ahead and give it a run and see. So it's generating, creating everything. And sometime soon we should have, there we go. The ocean's salinity is primarily due to the Earth's water cycle. Very good. It looks great. And it works. So now if I come here and just say Ollama list, we should see that we do have this new know-it-all latest, which is 2 gigabytes. It was created about 20 seconds ago. All right. Very good. So these are the things that we've done before using the CLI as well as using the REST API. But now we're using the Ollama Python library or SDK to do the same thing, because I just want to show you what's possible. So this is more flexible, as you see, because now we're actually using code and the power of the REST API in the back end to create very simple applications. Of course, this is just to show you what's possible. And soon enough, we're going to be able to create those large language model applications that are based on locally using Ollama models. So once we've done that, we can, of course, delete models. Okay, so we can say Ollama delete know-it-all. And if I run this, it's going to go ahead and run again and go ahead and delete our friend know-it-all. Okay, so I have the response again. But most importantly, if I go back and list, we should see that we no longer have know-it-all. Okay, so go ahead and play around with this, and I'll see you later. Okay, so now that you have all the tools, you understand what Ollama is, what problem it comes to solve, and how to actually build a simple, useful applications using Ollama, AI-based applications using Ollama. Now it's time for us to dive in and start building real-world use cases using Ollama. And let's go ahead and get started. All right, so now it's time for us to start building something useful, things that are actually useful. So the first thing we're going to do here is we're going to build a grocery list organizer, okay, or categorizer. So the idea is you have, for instance, a grocery list file, text file that has all these different items, okay? And so what we want to do is we're going to use the Llama 3.2, the model, with Ollama, of course, and see if we can recreate this entire grocery list and actually create a new grocery list from this, but categorized into categories. So for apples and all these things could be produce, and then we have snacks and so forth. Okay, that's what we're going to do. So You will have access to all of this code, of course, but you notice that now I have this data folder here, which will have this grocery list.txt with all of these items. And so let's go ahead and create a new file here called categorizer.py. And this is where we're going to start playing around. First thing, we're going to go ahead and import Ollama. And then we're going to import OS because we are going to interact with the directories and finding things. And at the top, we're going to I'm going to just add this model so we can use it. So it's going to be Llama 3.2. Okay, so let's go ahead and set up the paths. And I already have them set up. So let me go ahead and get that. So essentially, for input path, it's going to be data grocery list. So essentially, I'm going to data get this grocery list, and output is going to be data, and it's going to be called categorized grocery list.txt. So it's going to be under data again once all is done. All right, so the first thing is we're going to go ahead and check paths if the input file exists by using OS exist and pass this input file path like that. And we're going to print input file if it's not found, right? And then we're going to get out of there. And then we're going to read these uncategorized, and then we're going to read the uncategorized grocery items from the input file. To do so, we just open the file through the input file, the path, and read as F, and then we take all those items. We read everything, strip everything into our items. So these items now should have all of the items from our grocery list text file. And as we know, to direct our large language model, we need to pass a prompt. So to say, this is what you need to do. This is how you're going to be doing it, right? So it's kind of prompted to give it some directions so it knows not to veer off somewhere else. So for that, we need to have this prompt that I already created. So there is the prompt. So you are an assistant that categorizes and sorts grocery items. So we specify exactly what this model does. Okay. Here's a list of groceries. So items is going to be all of the items that we received there. Please, 1, categorize these items into appropriate categories such as produce, dairy, meat, bakery, beverages, etc. And 2, sort the items alphabetically within each category. So in each category that you put every item into, make sure you sort alphabetically. And 3, present the categorized list in a clear and organized manner using bullet points or numbering. That's it. So we can make this more complicated as we wish, but this should be fine. All right, so now we have the prompt. We have, of course, now we have the file. We have all of the items inside of this variable here from the text file, and we have the prompt. Okay, we're passing in that information through the prompt, so we can use that prompt then to send the prompt and get the response. Okay, so now what we do here, put inside of a try catch essentially. So we are generating, we're using Ollama generate, we pass in the model, and the model, remember, is what we set up here. Okay, and then we pass in the prompt. Remember, the prompt will have the items and of course the prompt to make sure that the large language model knows what to do. And then we have generated a response or text. We get that information if we have something, or we just get nothing. Okay, return nothing. Okay, so now we are writing the categorized list to the output file because we want to get that. What I can do also here is I can print real quick here the generated text, so which is going to be the actual response. So we can do that here just for fun. I can just say generated text or generated, or let's say categorized list. And so then we write into a file, and that's it. And we categorize grocery list has been saved, and we show the output file, the path. That's it. All right. Okay. That is pretty much it. So now we are going to go ahead and run this. So I'm going to open this, different ways of running. Just run here, or you can write the command for running, but that's okay. So let's go ahead and we'll what's going to happen. So things are happening in the background. And voila, you can see that we see the categorize list has been saved, data categorize list, and there it is. But also we wanted to show it here. Look at this categorize list. After categorizing and sorting grocery items, I present to you the following list. So produce, apples, all of these items. That seems correct. We have dairy, cheese, eggs, milk, and yogurt. Very nicely done. Meat, seafood, chicken, ground beef, salmon, shrimp, and sausages. Bakery, bread, flour, pasta, rice. Pantry, almonds, and all of these other items. Beverages, that sounds great. Frozen ice cream, snacks, chips, chocolate, and everything. And now if I go to see, as I said, we have here the categorized grocery list. If I click, it's going to be exactly the same what we saw printed out there. But now it is indeed a TXT file. Now, this is very small and very simple, but I hope it's showing you the things that you can do. And keep in mind that all of this is locally. We don't have to pay for ChatGPT or OpenAI API or anything else. This is something that is local to us. And keep in mind, we're using Llama 3.2, but if you, after doing some testing, and realize that for whatever users are trying to do, there's another large language model, another model that will fit with what you're trying to do, then obviously it's easy to swap that large language model to use that. That's the beauty. Because remember, here I'm saying we're using Llama 3.1, but I can go ahead and pull another large language model, another model to use. And nothing will change. All will change is just changing this to a different model. That is the beauty of Ollama. All right. So what I want you to do is perhaps to make this even better, or maybe you have some ideas that you may want to implement here because you have the large language model and you have some data. Maybe you have a list of something or a text that has something. You want to summarize it. Or you want to see what is the sentiment of that text and so forth. There's so many things that you can do. All of that because we are now have this capability through Ollama of picking and choose whichever model that we want to use. Incredible. All right, play around with this and I'll see you next. So now it's time for us to look at something a little bit more complex, something that you will find in the real world, which is building RAG systems with Ollama. So with Ollama, of course, we can build more complex large language model applications, as I have mentioned. So RAG, what is this thing? RAG stands for Retrieval Augmented Generation. So essentially is a way for us to converse or to talk or to chat with our own documents, our own data internally. Now, the thing to keep in mind is that large language models are actually very limited in terms of knowledge. So they're really bombarded with a lot of different information, textual, audio, and everything. That's how they were trained on, but they don't know what they don't know, meaning they only know what they were trained on. And so it makes it really difficult for us to build applications that are catered or that are customized to our own needs. So RAG solves that problem because now instead of the large language model to know only what it knows, we can actually use it because it's really good at predicting things, at summarizing and kind of brainstorming and getting pieces and pieces and putting together and get a response. We can use that to solve this problem by injecting, quote unquote, injecting our own documents. So that is one problem that it solves, but also we're solving the issue of hallucination. Because any large language models you've encountered, it makes stuff up because it knows a lot. But if you ask questions, sometimes it just doesn't know, but it doesn't say it doesn't know. It just says things that makes no sense, that may seem true, but they're false. So this is what we call hallucination. That's what RAG comes to help large language models and in turn help us when building RAG systems. Now let's go and have a deep dive into RAG. I think this is important, especially for those of us who don't really know what RAG is or new to RAG. Even if you already know what RAG is, I will just go real fast so you understand what really happens. An overview. So the idea is very simple, is that we have these documents, right? So PDF files, text files, whatever. And those are actually passed through this processing of parsing and pre-processing them. What that means is that all of those are chopped into small, tiny chunks documents. Okay? And those in turn are then put through an embedding model. What that does is it takes this textual information, these documents, chopped up, and now they're going to be converted into a vector space, into a number representation of those chunked documents. That's what embeddings mean, essentially. And once that happens, the vectorization of that's what happens, right? It's a different format now of this data, and that is saved into a vector database, okay? So all of this is what we call indexing. This whole process, we call it indexing. What happens then is that a user comes in with a question, a query. So that query, say, how old is the universe, for instance, is also taken in. And because of this whole ecosystem now is transformed into a vectorized system, that also has to be embedded. So the query is also embedded into a model, uses an embedding model to embed that, to vectorize this query. And so that is indeed what it is actually either passed onto the vector database or it's used for searching. Because now you can imagine if we are searching using text and this realm on this other side here, it's a vector database or Vectorstore, is saving everything mostly in vector. We need to have this correspondence, right, between we have the question, but it has to be transformed into the same format as what we have here. So that way it's easier to do this searching. And so what happens now is that these systems have what we call retrieval capabilities. So they retrieve the pieces that are needed for answering the question. Meaning, if the query is about how old is the universe, it's going to find all the pieces, all the documents inside of a Vectorstore that perhaps are close to that question, right? And packages it all up, and that's what's passed along with the prompt, right? The documents, these pieces that we retrieved, we call them relevant documents, and the query itself. And that is indeed what is passed through the large language model, so that the large language model has this contextual idea, sense on how to answer that question. So it generates an answer, which then we get a response. So in a nutshell, ladies and gentlemen, that is what RAG is, and is very powerful for the reasons that I've just shown you here. Now, what do RAG systems need? As you saw, well, they need a few things. First of all, they need a large language model because that is essentially what drives most of the things, essentially, because we get all that information, the documents, pieces of documents, related documents for what we are trying to ask for. And the prompt and everything, that's what it takes. And the large language model has so much knowledge, but also has these reasoning capabilities to know how to package it all up and answer that question coherently. And also we need this document corpus. So essentially it's the knowledge base, what we pass in through. The document embeddings is very important for the reasons I saw there, because you take these documents, you break them down into embeddings, small pieces of vectors. And if we need somewhere to save those vectors. These are not just normal databases. These are what we call vector databases. These are vector stores. So there are many out there. We have Face, Pinecone, and ChromaDB. And then we need to have this retrieval mechanism. And most vector databases have in them some retrieval mechanism to retrieve what needs to be retrieved to then be passed along downstream. When we want to build large language model applications, we can brute force everything and do everything on our own. But it's always nice to have tools that kind of help us and abstract out all the complexities of building large language model applications. And so that's when we use tools such as Langchain. So it's a tool that makes it really, really easy to deal with large language models and build robust large language model applications. Langchain is an amazing framework, actually, and there's a lot of things that it does. But one of the things that it does well is that it's able to load and parse documents easily. We can use classes and wrappers to split documents and chunk them up, generate embeddings, and many, many, many other things. Okay, so it provides this unified abstraction for working with large language models and building LLM applications. So tools are always welcome. Okay, so I thought probably would be a good idea to look into Vectorstore and embeddings as an overview. Now, it says here Langchain, but essentially this is just in general how things work when it comes to Vectorstore, embeddings, large language models, how to build a RAG system, and how everything actually works in the back end. Okay, so just relax and let's go through this. Okay, all right, so this is the idea. The main idea really, as we saw before, is that there's got to be some way of loading documents. So we need to load the documents that come in various forms. Sometimes they come in as URL, PDF files, text file, databases, and so forth. All of that is pulled together through as documents. Okay, this is document loading. And then it goes through the process of splitting those documents, as we saw. And then once this is split, of course, go through the process of embeddings and everything, and that is put into storage, right? This is a vector space or vector store. But it has to have some retrieval, as we saw, because this is the way of getting information related to the question, the query that comes in. Okay, so the retrieval goes through the vector store, finding things that are related to the question, and then get relevant splits, relevant documents, and that is all what's put together with the prompt and large language model and pieces of documents, and then large language model is able to give us the answer, the result. That's what we just saw. So the splitting, what happens? We go through the process of splitting, and the splitting documents or the chunks are then passed through the embedding model. So the embedding model embeds, creates this vectorized or this number system or number format representation of those texts or those pieces of information. Okay, so it looks something like this. Literally, the text is converted into vector embeddings, and it looks something like that. Okay, so embedding vector keeps the content and the meaning of the text intact. Now, this text so the idea is that the text with similar content and meaning will have similar vectors. And so if you look at this diagram here, this diagram hopefully puts everything into perspective. We said that text with similar content and meaning will have similar vectors. Now remember that in this vector space, high dimensional space, there's a lot of things going on, a lot of high dimension, right? So this is very simplified. So that means then if you look at cat and kitty in this vector space, in this high dimensional space, you can see that they are really close in meaning, because a cat and a kitty, they're essentially the same thing. But a cat and run, not the same thing, right? And so that is the representation. But if you look at the actual representation in the vector space vectors as vectors numbers, you will see something similar like this, because cat and kitty are pretty much the same in terms of the semantic, the meaning. They will have some sort of similar numbers somewhere. Okay, that's the idea. And that is actually what is stored into a vector database. These numbers, these vectors, okay? Those are embeddings. Now, the great thing is that vector databases can be used in various cases. Now, you can use all of this in searching. For instance, if you're building a system that wants to find relevant results to the query string. Recommendation systems, for instance, finding items with related text strings that are recommended. And classification, to classify strings by most relevant and similar labels. Okay, so these are some use cases that are used when we talk about vector stores and vector databases and vectors, embeddings, and so forth. Now, the whole embedding process works as follows. Number one, of course, we have documents that are split into chunks of text. We saw this. And then those are transformed into embeddings, which then are added or saved as embeddings into a vector database. Now, the great thing here is that most vector databases, they not only save the embedding vector, they also embed or save the original text split. So on one side, we're going to have the actual embedding vector, as you see here, and on the other side, the corresponding original text. So that's how most vector databases store things. So this whole process is extremely important because when we then are ready to query the Vectorstore for embeddings, in this case, this is what happens. First thing is we have here, as you see, let's put it all together. We have the question. This is the indexing part of thing. The question goes through the embed process because it has to be transformed into embeddings so that the whole system understands, right? And then what happens is that we go through the process of indexing here. So it knows essentially to look for what is going to be similar to this embed, which is part of this question. So search and compares all of the entries in the vector store, and then it picks out the most similar entry. And once those are picked, those most similar entries, those are the ones that are packaged up with everything through the large language model. So the large language model, what it will do is going to take the most similar entry found and pass them into with the query, the question, the pieces of documents and everything to then get the answer, the result. So that's how it all works. So I wanted to show you this so that you have an idea on how Vectorstore and the large language model, how everything comes together, and RAG systems. So now that we understand RAG systems, we understand how embeddings, large language model, how this whole thing comes together. This is the simple RAG system hands-on, or at least the overview of what we are going to be putting together. So the idea here is very simple, is that we're going to use Langchain to pass through the PDF file to load that, and then use Langchain's character text splitter to split that into small chunks, as we have discussed. And then we're going to use Ollama embeddings. This is the important part. Ollama also has a model for embeddings. That is going to allow us to embed all of this information and put that into a Chroma DB database. And then what will happen is that we're going to pass in a query, and we're going to use, again, Langchain's multi-query retriever that will be able to do all things that it needs to do to transform this query into embeddings, of course, and search the Chroma database with all those embeddings. And then pull out the most similar pieces of information or data or documents, and then put it all together, relevant docs, query, and prompt, and pass that through a large language model, which in this case, again, is going to be Llama 3.2, and of course, generate the response that we so desperately need. So this is a RAG system now using Ollama embeddings and using Llama 3.2, which is part of Ollama. Now, key point here is that for all these embeddings, Ollama embeddings models, and this large language model, we can swap these with whatever else that we might want to use, and the whole system will still work. Again, I'm repeating myself, I know. That is the beauty of Ollama, is that once we have the system set up, we can swap the embeddings, we can swap the large language model, these models, with whatever else that we want, and it will still work. Okay, so this is what we're going to be putting together next. All right, so first things here, I have this BOI PDF. We've seen this before, so you should have access to all of this anyway. It's just these beneficial ownership information report that I found online. And that's what we're going to be using for our RAG system. Okay. Now, one thing I've also added here is this requirements.txt. So this has all of the requirements, all of the things, the dependencies we need for all these projects that we're going to be working on. So I kept it here so that we can run, so also that you have it here. That way it's easier. You don't have to watch me always go ahead and type things and importing things and so forth. So you have, I may still do that, but you have this requirements.txt with all the dependencies. So the first thing I want to do, of course, is go ahead and run that real quick. So pip install.r requirements txt, like that. So it's going to go ahead and get all the dependencies. That was pretty fast. That's very nice. And we should be good. All right, very good. And next you can see that I have also created this PDF rag.py. This is what we're going to be working in. So I have a few things that we're going to do here. So I'm going to copy and paste in a few things. So first, we need to ingest the PDF files, and then we need to extract text from that PDF file and split into small chunks. So essentially the same things that we have been talking about in our presentation. And then we're going to send those chunks to embedding model, saved embeddings, perform similarity search, retrieve, and do all sort of things. Okay, so that's the overview of what needs to be done. All right, so let's go ahead and get started. Now, the first thing is I'm going to import a few things here. So this is from Langchain community. Now, this is working now because I installed a rand requirements.txt, which included Langchain community and other things. So important that this happens. All right, so we're getting the unstructured PDF loader and this online PDF loader here. Now, we may use one over the other, but you have both. And next, what I'm going to do here, I'm going to have the doc path and the actual models. So the model is going to be Llama 3.2, and the path to the document, just have one here, is data, BOI PDF. That's what I'm doing. Okay, so let's load the PDF file. Okay, so I use the unstructured PDF loader and pass the doc path, which is this one here. And then data is going to get all of the loaded information, right? Okay, so now I can go ahead and actually print for preview. So we see that things are actually working, and you know that things are actually working. I'm going to print just about 100 items from our content, from our data. Let's go ahead and run this fast. So in the back end, we should be able to do all the things like getting the information and load the document. And should be able to see soon here something. Okay, very good. So we went ahead and showed a few hundred words or 100 parts of the content that comes in our content data, which is the data that we loaded, which is our PDF file. Very good. So we see here beneficial ownership information, and that is good. So just to test it out to make sure everything is working. Okay, so that was the end of PDF ingestion. So we're able to get that PDF. Next, we're going to extract the PDF and do some chunking, essentially. Okay, so for that, we need a lot of help, of course. So I'm going to go ahead and get all of the imports. So what happens here is that, first of all, we're getting Ollama embeddings. This is a wrapper of Ollama through Langchain. That's the beauty of Langchain, because we have a lot of wrapper classes and methods and so forth. And then we have this recursive character text splitter, which will help us to recursively split our text. And then, of course, we have the Chroma DB through Langchain. All right. So first of all, let's go ahead and split things here. Keep in mind, all we're doing here is independent of large language models we're using. This is across the board. This is how you would do anytime you want to create a RAG system. All right, so we splitting everything. The chunk is 1200. So we're saying for each 1200 chunks, we're going to split. So we're saying each chunk will have about 1200. So we're saying each chunk size will have about 1200, and the overlap is going to be 300. So the greater the overlap, the better, because that means we are conserving the context. Okay, very good. And then chunks, we pass this text splitter, which should have all that information. Actually, this is all from the data that we loaded from here. And then we use text splitter and split the document. So now we have those chunks. And if we want to see, we can go ahead and print things out real quick here so you can see. Okay, so you can see that we have the number of chunks. First, it says here somewhere, number of chunks is 42. And we have the actual chunks, table of contents and all of that. So this is good. That means things are working. And the beauty of using Langchain is that it adds metadata to all of these pieces. You can see now we have this metadata was added called source is going to be data BOI PDF, which is real good. Okay. Otherwise, we will have to do all of that manually. Okay, so we know this is working. Let me go ahead and comment this out. Okay, now it's time for us to add into our vector database because we have those chunks and we need to add them. But how do we add to vector database? Well, first we need to do something first. We need to create those embeddings. If we go to Ollama, if we go to ollama.com and go to models, you find many different models. One of the models called embeddings, let's say embeddings, you can see that we have this nomic embedding embed text. We also have this Msty, embed large, and many others. Okay, we can use whatever we want, but this is the one we're going to be using. So click here, and you can see it's a high performing open embedding model with a large token context window, which means it allows you to put a large amount of text for embeddings for it to be able to embed. Okay, so this is what we're going to be using for our example here. That means we'll have to pull this in code. And so let's go ahead and do that. First, I'm going to go ahead and import Ollama, and then I'm going to encode, pull in this embedding. Now I already have this, so it's just going to go ahead and update. I'm just going to put this in a way so you have. And then what we need to do is to actually create the vector database. And it's very simple. All we do is say chroma from documents and pass the documents chunks. Remember, the chunks are here. And the embedding. Now we're using this Ollama embeddings and passing the model nomic embed text to generate the embeddings. So all of that is being passed through our chroma from documents function. And of course, we collection name, we just pass a name, simple rag, that's fine. Okay. All right, so continuing, let's go ahead and do the retrieval side of things. So how do we retrieve things and so forth? So first, let's go ahead and pass in a few things here. Now we need some help with Langchain where we can create prompt templates, as you see, and also a way of parsing whatever comes in or goes through this rack system. We'll see in a second here. So that's why I'm importing all of these. And while we're here, let's go ahead and also import a few other things, such as the chat Ollama, because that's what we're going to be using, that model, as our large language model. And then now we have this runnable pass-through. This is part of what we're going to see later, part of chaining that happens with Ollama, with Langchain. We have this multi-query retriever, as you see. It's going to help us with a lot of things because we're going to be able to retrieve documents. We're going to be able to give a query and use a large language model to sort of write a set of queries and pick up the best one to pass through the large language model. So this is all optimization under the hood. Okay, let's go ahead and set the model that we're going to be using. So this is how set model. Now this is a wrapper, Ollama wrapper, and we pass the model, which is Llama 3.2. All right, so we have the large language model already. Now, as you know, we're going to go ahead and use this simple technique to allow us again to generate multiple questions from one single question and then retrieve documents based on those questions, which allows us to get the best of both worlds. So this is the query prompt that I'm going to use here. So you can see here I'm using the prompt template. The reason why is because we can then pass things like input variables, which is going to be the question that internally will know how to pass around all these pieces of data. What you can see here, the template says you are an AI language model assistant. Your task is to generate 5 different versions of the given user question to retrieve relevant documents from a vector database. By generating multiple perspectives on the user question, your goal is to help the user overcome some of the limitations of distance-based similarity search. Provide these alternative questions separated by new lines, original question and pass the question, which is going to be passed along. So this prompt template here, it's going to be passed along soon through the retriever, and it will know how to deal with all of that. This is beautiful because we're using Langchain, and it does everything automatically for us. All right, so now let's go ahead and actually create our retriever. So our retriever here, we're going to use the multi-query retriever from large language model, and we pass a few things. Okay, we have the vector database, so we need, of course, the vector database that we created here, and then we're going to transform it into a retriever. So retriever will know how to retrieve things from database. It's going to return something. And we need to pass the large language model because it needs to know how to take that item, all those information retrieved, and how to process that. And with that, we also need the prompt. So you remember in the diagram, when it comes to once we have everything set up, we'll retrieve information, we'll retrieve pieces. In this case, we're retrieving pieces that are similar to the query that we're passing along, which is inside of a prompt. And then we need the large language model, which is going to drive everything. It's going to use all that information, compact everything, and be able to answer those questions. All right, very good. And next, we're going to use create the RAG prompt. So let's go ahead and do that real quick. So essentially, it's another prompt that we can use. This is our question that we pass along. Okay? A RAG prompt, this is just another template we're going to pass. It says answer the question based only on the following context. So we're going to pass the context and the actual question. This context and everything is going to be passed along, as you'll see later, right? Internally with Langchain. Okay, so once we have that, we need to create an actual chat prompt from all of that. So we use chat prompt from template and pass this template here. So these wrappers here internally will know how to pass in this context, how to pull in the question and so forth, because these come in as just variables. Okay, and once we've done that, that's when we then put all of that into a chain, which is going to go through the process of pulling in all the pieces that are put together so that we can get the result. So essentially what it means, what is happening here is that we pass the context. We know the context is going to be the retriever. Retriever will know, as you saw here, how to get things from the database. It knows the large language model that's going to be driving everything. It also knows the prompt, which we created here, which has a few input variables we're passing along. So we're putting all together, and then we have the question, runnable pass-through. Let's just say, just pass-through, don't mind much. And then we have here a chain to pass in a prompt, and then we need the large language model again. And then at the end, once we have the result, we're going to pass that through a string output parser. So essentially to parse everything out to make everything clean and nice. All that is done, we can just start asking questions. So I'm going to comment this out. Let's start with the main question at the top here. Say, what is the document about, for instance? Let's go ahead and run this. So this is it. This is our full-on RAG system. Let's go ahead and run and see if this works. Okay, so done loading, done splitting document, done adding to vector database. Very good. Okay. It says here, the question, the answer says, the document appears to be a set of instruction for reporting beneficial ownership information, especially the BOIR, filing instructions, provide guidance, and blah, blah, blah. Very good. That's exactly right. And so now we can pass questions. So that's one question. Let's see if I go and comment this out. I want this second one. What are the main points as a business owner I should be aware of? Let's go ahead and run again. Now, this is very inefficient because in a way it goes back and does the splitting and adding everything, but that's okay, just to show you how things are done. Okay, look at this. As a business owner, you should be aware of the following main points, and gives us all the points. And let me do another one here. Okay. Based on provided text, here's how to report beneficial ownership information, BOI to FinCEN. Complete filing, and there we go. All right, so it is indeed working. We were able to put together a full RAG system, be it we could improve in terms of repetition of, splitting into all the things, that's okay. But you can see that it works. We use a large language model, in this case, one large language model from our own, in this case, Ollama, Llama 3.2. And then we used embeddings also from Ollama. Just like that. Again, we can just split around, we can change the models that we're using and leave everything as is, and it should work. Very good indeed. So I hope you're seeing the benefits here. Number one, again, remember, is that we don't pay anything. We can run this as many times as we want. We're not paying anything for any hits to the API, in this case, OpenAI, or anywhere else, because this is local, which is really, really awesome if you ask me. So I hope this is helpful, and take this code and change it around, make it your own. Maybe you have a different PDF file that you want to converse with, or whatever else that you need. So go ahead and play around. This is your code. You have access to it. And so just do it. All right. So we finished this PDF rag. It works fine. And so I decided actually to show you here. I have the other piece of code, which is exactly the same. That's the same thing. But I call this PDF rag clean. So essentially it's the same thing as what we've seen. It's just that it's a little bit cleaner and looks better. Okay, so essentially at the top here, we have some configurations and blah, blah, blah. And we have this doc path. We have this model name. So this created constants at the top here, and vector name as well. Okay, so we have a function here called ingest PDF. Essentially that we just pass the doc path and it does all the things that it needs to do. We have the split documents function. And this is exactly how you should do it, right? Split everything into modules. And then we have this create database, and it returns a vector DB, and we create a retriever and everything. And we're passing along the templates and all of that. So essentially, like I said, what we've seen before, but now in a more cleaner way. And then we have this create chain, which creates the chain for us as we saw before. The code is still the same. And then we have this main. So now we just call, for instance, get the data by calling ingest PDF. And then we get the chunks, vector DB instantiation, the LLM instantiation, and retriever. And then we have the chain. And then we have our question, right? So we can add a different question here. Let's go ahead and run this. We should see the same thing essentially, but just different code, which is cleaner. Okay, so it's doing all the things. Okay, so there's a lot of good logging that's happening, and voila. So at the end, it responds according to instructions. This is what we have. So nothing out of this world, the same thing, but this is way better because it's way organized. So you have both and you are set. And because it's always nice to have some sort of a user interface, I have another version you have access to called PDF rag Streamlit. And in this case, when we run this, we should be able to have a user interface using Streamlit. So essentially, obviously, it's the same code. It's just that we have at the bottom here a Streamlit. I mean, look, see, setting up the title and user input and everything else. Okay, you can look at this code, but it's not out of this world. So let's go ahead and run this so I can show you real quick. Okay, there we go. So now I can, let's see. So it's going to go generate response. First it's running the load vector DB. And in a few moments, hopefully we should see an answer. Okay, so to file for beneficial ownership information, there we go, all that information. Very good indeed. And I can say, what's the penalty for not filing? There we go, and it gives us the information. All right, so there you have it. Now you have different versions, and this is the user interface version that you can see that we are conversing with our rack system, with our document. So quick break here. I just want to let you know that I thank you for being here, for learning this awesome tool with me here. I do have something for you as a way of me saying thank you for being here with me, and I appreciate you watching this video, this mini course. I have an Ollama pack that you can download that includes source code, code templates, and many other things that it's going to be a surprise, and you can get that for free. Obviously, so you go in the link in the description and you can go and get this Ollama starter pack. All right, okay, let's continue. All right, so the next application that we're going to be building, we're going to still use Llama 3.2, but you can always change the model. And this application is going to be a full-fledged application that allows us to actually use Swarm framework, which is a new OpenAI framework that allows us to create agents that will actually be able to delegate certain tasks to other agents and do different tasks. So this is going to be a full-fledged application, an AI solution application that you can actually use in real world. Most of the ones that we've been doing, you can use in the real world, of course, but this one is something that is actually, I would say that it's usable. So if you want to get a job, usually you have to find somebody who will have that job for you. Okay. And usually you have to go through recruiters, and recruiters usually work in an agency. And it's a slew of process, a lot of people that are involved usually to get you matched with an employer. And so in this video, I'm going to show you how to take this whole agency with different people working, these are recruiters, how to actually create AI agents that will do exactly what the real recruiters do. These recruitment agencies have a lot of moving parts. And one of the things that can be very difficult is that one, they need to vet people. They actually have to, of course, read the resumes, and they are getting many of those resumes and have to go through each one of those and contact people and trying to figure out their qualifications and how would they match them to an employer. What would be a solution? Well, you know this. Drum roll. Yes, the solution would be AI agents. With the AI agents, they're going to be able to pass along different tasks to other AI agents to do exactly that, from extracting information and then analyze their resume and maybe figure out how to connect or how to match to different employers or different positions, and then have a full report with recommendations so that the whole agency knows what is the process that went through to get to that conclusion where X person or X, Y, and Z people need to be matched to a certain company. And so that is exactly what we're going to be doing in this video. I'm going to show you how to use a large language model, in this case Llama 3.2, to aid us in this. On top of that, we're going to use a Swarm framework that allows us to create agents, AI agents, very quickly, simply, and to the point. So let's go ahead and build a recruitment agency, all with AI agents. So here's what we're going to be building. So here is the user interface. So it is indeed a UI recruiter agency. So you can go ahead, of course, and upload things, but most importantly, you can see we have this about that we're going to click. It gives us some about this whole thing. Now, of course, here is saying Ollama 3.2, the framework, Swarm framework, and all the things. So it says here, our system uses specialized AI agents to do what? Well, to extract information from resumes and analyze candidate profiles and also match with suitable positions, screen candidates, and then provide details, recommendations. So this is going to be a full-fledged agency that we're going to be building using code and Llama 3.2. Okay. Of course, the front end is going to be Streamlit, which is what you see here. So the idea is very simple. And let me go back to the upload. So here, what we can do is we can go ahead and upload files. Now I already have a resume that I'm going to go ahead and just drop it right there. So you can imagine now things are going to be happening in the back end. So the analyzing of the resume is happening. Well, first of all, different agents are doing what they need to do to get started. So the first agent is going to go ahead and pull information from this PDF file, which is a resume, and then it's going to pass on to different agents that will analyze and do all sort of things. So this is going to take a little bit, and then at the end, the main agent is going to be able to give us recommendations through analysis. And there we go. We can see that we have now this analysis complete. So we have a recommendation. So we have analysis. I can also close this tab menu there. So skill analysis for Janine, Nell's resume, and gives us sales engineering, industrial engineering, project management, and all this great stuff. So it pulls in all the information from the resume. And at the end here, you can see recommendation to enhance Janine's Nell's profile. Consider the following: add more experience, develop technical expertise, increase education and training. Confidence is 85%. Wow, it gives us the confidence that this person could potentially do well in a certain industry. And of course, I'll show you that results also have been saved locally. But you can see also have other things here. We have this job matches. It tells us exactly this person matches well 80% in New York for this data scientist position. All right. And we have this software engineer position, and it says that the match is 70% and it's remote. So this is exciting. That's exactly what we're going to be building. And also we have the screening here. Screening results gives us a summary of everything, qualifications, and the percentage, experience relevance, and all of this information. All right. And of course, we have another tab, the final recommendation. They give us the recommendation. And all of this, ladies and gentlemen, is built using AI, but most importantly, using AI agents. You can see how helpful, how useful this tool can be. By the way, if you are interested in being a part of a community where you find like-minded people to build AI tools from scratch, and you will have templates, we have weekly, monthly calls that we have for Q&A, and many other things in this community where people are actually building AI solutions. You'll have everything you need to build AI solutions using code and AI tools. It's a place where I'm very proud about, and there's a lot of people who are enjoying this community, and I would love for you to join the community where you'll be able to dive deeper into building AI solutions that actually solve problem. Okay, so let's go ahead and get started. All right, so I already have the code, and because of the nature of this project, there's a lot of moving parts, and there's a lot of code as well, not too much. And so what I will do, I will just walk through the code, and no worries, you're going to have access to all this code. But what I want you to keep in mind is that you can take this and apply to something else. So that is the beauty of using agents. That's the beauty of building these solutions, AI solutions. So I have here inside AI Recruiter Agency, and we have this folder called Agents. Let's focus on that real quick. But at the center of everything, the way I wanted to organize this code is that because each agent will have to have access to the large language model, in this case, we're using Ollama. That's another point here, is that in this case, we're using Ollama Llama 3.2, which means you don't have to pay for inference or pay for an API key, which is really great. And it's really good because then you can build these systems, build these AI solutions locally, and test them out before you can push them to production. So that is one of the great things about using Ollama models. But the idea is still the same if you want to use different models. Okay, so at the center of everything, the way I organize this code is a little bit more organized in a sense where you would find in a production application. Now, there are a few things here that you probably will have to kind of work around to make it production ready, but I put the code so that it is a little bit more organized. We're using classes and everything. Now, if you don't know a lot about classes, Python, it's okay. I have a lot of videos where I talk about Python, but this is how you would usually want to put together a potentially production-ready application. At the center of everything, we have this base agent here. What is this? Well, it is indeed a class. I'll make this smaller so you can see. As you can see here, it's a class called base class that we pass in a few things in its constructor. So when we call base class, which is going to be that all agents are going to inherit from, which means they're going to model after, this is what we have. So each agent, of course, has a name, instructions. So this is the model way that we do with agents. We're using Swarm. That is what we're using here. And you pass in, of course, the OpenAIs. Now, because I have another video where I talk about how to use Swarm and OpenAI, but override OpenAI in this case so that we can use Llama 3.2 or Ollama, any Ollama model. Okay, so this is how you override that. I have another video where I talk about that. You can find somewhere here, or you can just search on my channel. Okay, so what do you do here? We pass a base URL, and instead of having, in this case, the base URL that would have been for OpenAI, we have our own base URL. So this tells us that this is going to be locally using Ollama, in this case, pointing to an Ollama model. Okay, and then we pass API key here, just Ollama. It's not required, but it needs to be passed around. So at this point here, when we instantiate this base agent, we're going to know that we're actually going to be using, instead of OpenAI, because we're using Swarm framework, we're going to be using our local Ollama models. Okay, and then we have this function here that is defined called run. So this will get, of course, the message is going to be a list. And then we have this query Ollama. So at this point, we're going to pass a prompt as a string, and then we're going to go through the process of calling our client, Ollama client, which was created here. And then we say, hit the chat and completions that create. So in this case here, you notice we're passing the Llama 3.2, and we have messages. In this case, we have system, and we pass the self instructions. So these instructions will have passed along through the agent. Okay, so this is how you structure it. I know for some of you this may be a little bit advanced, but it's a good exercise. And we're going to pass temperature and tokens and all of that. All right, and then we return the response. So whenever we say query Ollama, this is what's going to happen. We're going to pass the model and then the messages. All of that is going to be passed along, also the prompt and the instructions. Okay, so here is this helper function here, parse JSON safely. This is just going to get the text that is coming in. As I said, safely parse JSON from text, handling potential errors. That's all we're doing here. So that is the base agent. So now once we have this base agent, what we need is to create the actual agent, Swarm OpenAI agents. And if I go back here, you can see that I have a bunch of agents here. So these agents, we have, for instance, the extractor agent, as the name implies, is going to be responsible for extracting information from the PDF file. And then we have the match agent, which is going to match whatever we got from the extraction, in this case, the PDF, and try to match it with the company or the position that the person may be a good fit for. We have the orchestrator, and we have profile enhancement, recommender, and screen agent. Let's start with screen agent, because all of these agents will essentially, in terms of code-wise, they will look pretty much the same. Now, this is important. Look how beautiful this is. So the screen agent here, we are creating a class just to make things simpler and scalable. And then it's inheriting from the base agent, right? Because the base agent, as we saw, has all the properties, all the functions or methods that needs for it to actually become an agent. So that's what we're doing here. We're initializing everything. So we are initializing the names to be screener, and we have the instructions here to say screen candidates based on qualifications, alignment, experience, and everything. So we're passing the actual instructions for these agents. We say provide comprehensive screen reports and all of that. And we have the run. So this is just going to go print to say, okay, screener conducting initial screening. That's all that is this, the run function is going to do. And then we have workflow context here. We are evaluating getting information from our messages that we're getting, and then get the content. So essentially, we're going to get what the large language model in conjunction with the agent, the results, and pass that into the query Ollama. And if you remember, if I command click query Ollama, what does it do? Query Ollama model with the given prompt. So now we get that information we got and then pass through Ollama, this agent here. Well, it's a call essentially to this endpoint so that it knows what to do. And then we get the response. And of course, we return an object, or in this case, a dictionary, which is going to have screening report. And we're passing in the date here. We could make this more dynamic, but this is okay. And screening score 85 in this case. Right, so let's go ahead to another agent. Let's go to extractor agent. So what does it do? Well, this extractor agent, as the name implies, it just extracts the information from a PDF file. Okay, we're importing a few things here. But the idea is very simple. Again, it's base agent is the base agent that we pass, right? That's going to be the model for this extractor agent. And we have the name, instruction, extract, and structure information from resumes. Focus on personal information, work experience, education skills, and certification, and all that. Provide output in a clear, structured format. So it's important that we make these instructions very direct and very concise. Okay, we have the run again. So in this case, it's going to show us this extractor is processing resume, and we do exactly the same thing as we saw before. So like I said earlier, most of these are going to be the same in terms of the code, right? And we extract everything, and also we extract the text, in this case from the PDF file, because we're going to pass that along. As we take, of course, the raw text that we should have at this point, and we pass along to query Ollama, as you know what it does. And then, of course, we return again the raw text, the structured data, in this case, the structured, I should say, information, and the results. So we're just returning a dictionary so we can see what's going on. All right, so it's pretty much the same. Let's go to matcher. The matcher here, you know what's going to do. It's going to match whatever it was extracted from resume, trying to match with certain positions that they might have. So it's a matcher, the same thing again. That's the beauty. And the instructions here is that match candidate profiles with job positions, consider skill match, experience level, location, and everything. Return matches in JSON format with title, match score, and location fields. Okay, the same thing as you see here. This run, it's going to print matcher, finding suitable jobs, and all the great stuff. Now, here is where we're just passing sample jobs. So this is where you would perhaps hit an API that you might have somewhere with a lot of different jobs, or a PDF file or a CSV file, whatever you have that would have different jobs. So in this case here, we just have this sample jobs with a few titles and everything. So that's the beauty. You can just plug in the source where you'll have a list of different jobs with requirements, locations, and everything. Okay, very good. So that's it. That's what's going to be used for the matcher to be able to match. It's going to look at the information that it's received from other people, in this case, other agents, and find the match. Okay, so match response. So this is where the matching results from Ollama come in. So what we do, we call the query Ollama, and we pass this F string here. Analyze the following profile and provide jobs matching valid JSON. Okay, so we have the profile here. It's going to be, and passes in, okay, the analysis, because in order to analyze, in order to do the matching, it needs to have the pieces that it needs. In this case, the analysis results that were gotten from a different agent. Okay, and then we pass the available jobs is this. So here's return only a JSON object with this exact structure. So it's very important to usually guide the large language models when it comes to the formats that you want. Okay, and there we go. So this is the format that we have here. Make it smaller so you can see everything. And then we can parse the response to make sure that we get everything in. This is parse JSON safely function that we saw in the agent, I believe, the base agent. Okay, we have some fallbacks here for errors and everything, and then we just return the parsed response. Now, before we go to the orchestrator here, let's go to the profile enhancer agent. So what does it do? Well, this is going to kind of enhance the profile as the name implies. It's going to go ahead and pass in the extracted information. It's going to copy that information and enhance essentially the profile of that candidate and return that enhanced profile. Essentially to extract what needs to extract and put all nicely. Okay, and then of course, the profile agent here, that's where we pass, we call agent, profile agent, and pass Llama 3, and we say enhance the candidate's profile based on the extracted information. So this is where we actually call, this is where then we pass this function that we created here, okay? And pass it through the agent because it will know that is the function it needs to run. Very cool. All right, let's continue here and let's go to the recommender agent. So recommender agent, as the name implies, it's going to be the same thing. It's going to recommend, right? So we have instructions here. Generate final recommendations considering extract profile, skills analysis, and provide all this information. So again, nothing new here. And of course, we're printing everything when we run. In this case here, we do the same thing. We call the query Ollama and pass a workflow context. So essentially is the information that we're getting from the evaluation of all the messages that come in. Okay, and then we return the recommendation. This is going to be sort of a dictionary with a timestamp and confidence level. In this case, we just say hi. Okay. Of course, you can add more things to make it actually realistic, but this is pretty good. Okay, let's continue. Let's go to screener agent. Now, the screener agent, I think we looked at it. Well, that's exactly what it does. It screens to make sure everything is good and pass it along. All right, so that is what it does. It's very simple. The same thing again. And there you have it. Now, the most important thing here, again, to keep in mind is that everything is base agent. So that means all these agents have a parent class that sets everything up. So that is the best way for you to think about when you're building real world applications or solutions. All right. Okay, let's go ahead and look at the orchestrator. The orchestrator in this case is the one that orchestrates everything. That is the maestro, if you will. Okay. And so it has a lot of things. Of course, we have to import all of those, but again, it is still an agent. So it has to inherit from base agent. So we give it a name, we give it instructions. Now, instructions are very important for agents. Okay. Says here, coordinate the recruitment workflow and delegate tasks to specialized agents. Ensure proper flow of information between extraction, analysis, matching, screening, and recommendation phases. Maintain context, important. Maintain context and aggregate results from each stage. Okay, so we got self, that's set up agents. So there's a function that is being called that goes ahead and initializes all the specialized agents, all the ones that we talked about. Look at that. Okay, very good, because as an orchestrator, it has to know which agents that it has access to start delegating. We have the run again, the same thing we've seen. And then we have this process application. So essentially it's going to just go ahead and pass some information here along and print out orchestrator starting application process and so forth. So we extract the resume. So it's going to go ahead and run to go and extract resume, update, in this case, the work context, workflow context. And then we analyze the candidate profile, okay, called self analyzer, to start the analysis, right? So in this case, we're calling all of those agents, right? You can hover over, you can see it is indeed an analyzer agent, okay? And then we update the workflow context here. So each step of the way, as we're calling these different, or the orchestrator is calling these different agents, is going to do what it needs to do, okay? Delegate and create, in this case, add to the workflow context. Okay, and does with matching jobs, screening candidates, and then we generate the recommendation. All right, so it calls the recommender and does exactly the same thing, and we have some exception just in case things don't work. And that's pretty much it. Now we have other things here, logs and everything, but that's something that you can take a look yourself. But this is it. And so once we have that, we also have, of course, the app.py, I should say. So this has some code with Streamlit, which allows us to look at something that is nice to look at, as you saw earlier. Okay. So at this point here, let's go ahead and do a quick run. So we say Streamlit run app.py, and what will happen is going to go ahead and open our agency. AI Recruiter agency. We'll have a broken link here, but that's okay. We can go to about, for instance, and tells us about this agency. It's very, very cool what it does and everything. And all of this was created using Streamlit. And then we go to upload. Now we can actually browse and upload something, a resume. So I do have a resume that we can go ahead and upload. I'm going to upload here real quick. And the moment you upload that, drop it, and it's going to start the process. And the cool thing as this happens, I have here logs that are actually being sent out. And also I have what's happening in the whole orchestration showing here. Orchestrator starting application process and is analyzing everything, and it's working. It will take a little bit because there's a lot of things are happening. And you can see all of that happening here, right? It tells us orchestrator starting, analyzer did that, matching, screener, and recommender, and it's happening. So we're gonna take a little moment here until hopefully we get the final results. Okay, so after a little bit, you can see that then we have here analysis complete. How cool is that? So we have different tabs here with different information, right? So we have skills analysis. It tells us exactly what happened, key skills and expertise level, and goes over everything about this candidate, 2 years of experience, and it gives it, so it's extracted everything from the resume and qualifications, and also even some subjections, right? However, the fact that her master's degree is not explicitly mentioned in her work experience section raises question about how much of her degree was applied in real world scenarios. So these are agents, just like, you know, real agents who would have to think about whatever they are thinking, whatever they are analyzing. So career progression, potential red flags, look at that. All of this, okay? And the confidence score is 85%. And here, if I go back to the next tab, look at this. Job matches, data scientist, 75%, New York, senior software engineer, about 60%. All right? We can look at screening. So the screening results, 85% of screening results. So confidence, based on the provided information, I will perform a comprehensive screening of Janine Nell's resume. Qualification alignment, it goes through all of that. So all these agents were able to work together to come to a certain conclusion. Okay, and we can go through and all that. And also it says results are under results analysis. So we also create a textual file, txt file, with all this analysis. Okay, and I can go recommendation, and based on this analysis, I would recommend that Janine Nell develop more explicit examples, expand her professional network, and all of these different things. All right, there you have it. So just like that, ladies and gentlemen, if you not excited about this, I don't know what really will make you excited. This is something that you can actually use. It's usable, right? You can imagine that if you have, in fact, here's what I will do. If you have a friend of yours who is a recruiter, show them this video and see if they could use something like this, right? Don't make them feel like their jobs are in jeopardy. No, but just ask them if they could use such thing. How much time they will save them daily from vetting people and all that. All right, well, thank you so much for going through this course, and I really hope that this course was helpful and that you can see the power that we get when you use Ollama, because now we're able to pick and choose different models, and we can build really good AI solutions locally without having to spend a dime. At least you will have to have a computer, of course. You don't have to pay for OpenAI keys and all of that. So I hope this was useful. I hope this was helpful to you. The other thing also I've been hinting throughout this entire course is that I do have a surprise for you, which is what I call Ollama Starter Pack, which will have everything that you need to get started with Ollama, from code templates and other things that are surprise. So you should see a link in the descriptions. If you don't see it, you can just leave a comment as well. I'll show you the link where you can go and get all of that. Again, thank you so much for your time, and I really hope this was helpful. If you have any questions at all, just leave them below, and I'll do my best to serve you, to answer them. Thank you again. Till next time, be well.